So, we might be getting closer to finding a massive icy planet beyond Neptune's orbit. Sorry Pluto, still not you. Recently, some universe mapping using data from a telescope in Hawaii eliminated about 78% of the possible locations for this mysterious Waldo from space. Some people call it Planet 9, while others prefer Planet X. Either way, it's been causing controversy since its existence was first proposed, and that is mainly because no study so far can answer the big question: does it really exist? If discovered, Planet 9 would rank as the 5th largest planet in our solar system, with a mass 10 times that of Earth. It's also theorized to be gaseous, like Uranus. The initial study on Planet 9, dating back to 2016, suggests that this colossal new planet orbits the Sun 29 times farther out than Neptune, which sits at about 2.8 billion miles. As a result, the Planet 9 would take between 10,000 and 20,000 years to complete a single orbit around the Sun. If confirmed, this yet-to-be-understood world would dominate a region larger than any other known planet in our cosmic neighborhood. These are all intriguing hypotheses, but without a single piece of evidence or observation to back them up. Before dismissing this as a wild guess, it is important to note that these researchers relied on complex mathematical modeling and computer simulations to speculate about the planet's characteristics, because that's what they do. The hypothetical presence of this planet would explain various mysterious features located beyond Neptune. We are specifically talking about the Kuiper Belt, a huge donut-shaped region filled with icy debris left over from the formation of the solar system, including comets and dwarf planets like Pluto. What happens is that the 6 farthest objects in the Kuiper Belt exhibit elliptical orbits that are all oriented in a similar direction within physical space and tilted approximately 30 degrees downward relative to the orbital plane of our 8 known planets. What's strange here is that, despite their distinct orbital velocities around the solar system, they maintain this alignment. The likelihood of such alignment occurring randomly is extremely low, around 0.007%. So, here comes Planet 9, a hypothetical massive celestial body that offers a plausible explanation for this strange phenomenon, potentially exerting gravitational influence to shape these orbits. The initial theory didn't hold up for long, facing accusations of observational bias and calculation errors. Then, in 2017, another study popped up, sparking back the idea that maybe Planet 9 is out there after all. This time, Spanish astronomers tried a novel approach, focusing on observing extreme trans-Neptunian objects. These celestial bodies orbit the Sun in highly stretched elliptical paths, with average distances exceeding 13 billion miles. The research suggests that the distances between these objects' nodes and the Sun might provide clues to Planet 9's location. You see, these nodes are the points where a celestial body's orbit intersects the solar system's plane. When these objects reach these points, they're more likely to interact with other solar system bodies, potentially causing significant changes in their orbits or even collisions. So, if the trajectory of these extreme trans-Neptunian objects remains stable, everything's fine. But if it's not, well, that's a sign that something else, something big, is messing with their path. And that's exactly what the research found. There is something unseen out there, throwing these objects off course. And that something could be a planet, chilling at a distance between 300 to 400 times farther from the Sun than Earth. To this day, the study of the extreme trans-Neptunian objects is the strongest evidence we've got for Planet 9's existence. And if you're still not convinced by this theory, know that strange motions like these have led to planetary discoveries before. Neptune, for instance, was spotted because Uranus's motion didn't quite agree with the predictions of Newtonian gravity. But the deflection of its orbit could be explained if it was caused by a pull of an undiscovered planet. And just like that, we discovered Neptune. Now, the year is 2021, and there's all this buzz about Planet 9 again. After correcting some old guesses, studies are now leaning towards the idea that this mystery world follows an epic loop around the Sun every 7,000 years. That is massive news, because it means this planet might be closer than we ever thought, making it easier for our telescopes to spot it. The paper also suggests there is a whopping 99% chance that the funky orbits of these distant objects are all because of this unseen planet, not just some cosmic coincidence. Now, the odds of this whole situation being a fluke are down to a 1 in 250 chance, which is much better than the 1 in 10,000 chance back in 2016. All these optimistic numbers have brought us to where we are today, keeping our hopes and working on better equipment to continue the mission of spotting Planet 9. As mentioned earlier, researchers in Hawaii created some kind of treasure map utilizing the Panoramic Survey Telescope and Rapid Response System to eliminate 78% of its locations. This is great news, considering how challenging it is to find a planet-sized needle in a cosmic haystack. But unfortunately, Planet 9's presence remains a ghost in the dark outer reaches of our solar system. Enthusiasts are still convinced of its existence and believe it is only a matter of time before we celebrate the discovery of Earth's new cosmic cousin. They're putting their hopes on the Vera C. Rubin Observatory, which is currently under construction in Chile and is scheduled to begin science operations in late 2025. Over the course of 10 years, this observatory will scan the entire southern hemisphere sky every few nights with a 27-foot, fast-moving telescope equipped with the largest digital camera in the world. The idea is to catalog everything in the solar system, reaching out to and beyond Neptune, and tracking the movements of millions of celestial objects, including space junk, asteroids, comets, and stars. If Planet 9 is indeed out there, this next-generation telescope could be the one to find it. The existence of this mysterious planet is far from being universally accepted in the scientific community. That is simply because Planet 9 isn't the only explanation for the strange phenomenon occurring beyond Neptune. One theory suggests that a group of distant objects, such as dwarf planets, comets, and moons, might be collectively influencing the orbits of the extreme trans-Neptunian objects. Others believe that a black hole is behind all this. These compressed masses are some of the densest objects in the universe, potentially capable of affecting the orbits of other masses, like how this supposed ghost Planet 9 is believed to be doing. Another bold perspective suggests that our current understanding of the laws of gravity is flawed, actually incomplete. This theory, known as modified Newtonian dynamics, proposes that these distant icy objects exhibit strange behavior not due to influence from another planet, but rather because the immense gravitational field of the Milky Way is influencing them. However, even supporters of this theory acknowledge that it is too early to draw firm conclusions, and much more extensive research is still required. While we continue our relentless hunt for Planet 9, some astronomers have taken it a step further, suggesting the existence of a hypothetical Planet 10. This world has a mass and size like that of Mars or Earth and is located on the edges of the Kuiper Belt. But the thing is, if this alleged Planet 10 is indeed as small as scientists believe, it might not have enough gravity to clear its orbit of debris. And that is pretty similar to what happens with Pluto, being one of the reasons why it got into trouble back in 2006. So yeah, it's better not to get too excited. This supposed Planet 10 might end up classified as another dwarf planet.
Usually, when we look at the photos of astronauts in space, we can see that they're sort of attached to the spacecraft. But there was one brave astronaut who took a wild step into the great unknown without any safety line connecting him to the shuttle. This brave man was Bruce McCandless, and he did that stunt back in 1984. How did he come back, you may ask? He did this cool trick using a nitrogen jetpack, which NASA called the Manned Maneuvering Unit. At first, he tried out some test maneuvers in the Challenger's payload bay, and only after he made sure it was alright did McCandless decide to go for it and glide a staggering 320 feet away from the shuttle. A bit of sad stats here. Out of the 430 people who have made the leap into space, 18 have sadly lost their lives, which gives us a fatality rate of just over 4%. With these numbers, it's safe to say that space shuttles are the least safe means of transport out there. Duh. Alright, let's make it a tad brighter. If we crunch the numbers a bit better, we can get a smaller percentage. But how? Well, 4% is a bit misleading because when we count, we take all the space flights. However, some people flew several times, which reduced the probability. With over 600 seats filled across 113 shuttle flights, the true fatality rate for shuttle missions is actually closer to 2%. Let's test your general knowledge now, shall we? So, what was the first living thing ever sent to space? If your answer is a monkey, you aren't right. Those who said dogs, sorry you guys, but it's not correct either. On the 9th of July 1946, fruit flies became the first living creatures to make it to space during a suborbital V-2 rocket flight. Then, on the 20th of February 1947, these little guys safely returned from their journey, opening the door for future human space exploration. Before, we sent to space mammals like the rhesus monkey, Albert II, in 1949, or the famous space dogs. Scientists spent a lot of time studying fruit flies to see how they reacted to radiation and the conditions of space travel. Researchers started using fruit flies for experiments back in the 1910s. Guess why? Because we humans share a lot of genes with these yucky pests. Imagine hearing some creepy music all of a sudden, when there's nothing but darkness around you and nobody is there to help you. Right, now imagine how elevated this experience was for astronauts who heard some creepy music in their space shuttle. Months before the moon landing, Apollo 10 astronauts were orbiting the moon, testing equipment, when they heard strange audio noises. Astronaut Eugene Cernan noted the eerie sounds, joking they were like weird music. At that moment, the astronauts didn't have contact with mission control. They were over the moon's dark side. Although the noises resembled something from a sci-fi film, NASA downplayed them as they were focused on the astronauts' mental health. Despite years of speculation, the source of the sounds remains unknown, with theories ranging from radio interference to charged particle activity. Cernan later remarked that they didn't take it seriously and didn't report it after the mission. Chances are, we've already received messages from new friends from other galaxies, but we just failed to understand them. In August 1977, some astronomers using the Big Ear radio telescope at Ohio University picked up a strange narrow-band radio signal from the constellation Sagittarius that lasted for 72 seconds. The signal buzzed at a frequency of 1,420 megahertz, which is significant because it matches the natural emissions from hydrogen. This frequency had been flagged by scientists almost 2 decades earlier as a likely choice for extraterrestrial civilizations trying to reach out to us. They dubbed it the WOW signal after one of the astronomers wrote "WOW" on their printout. We've never heard that signal again, and no one has been able to explain its origin satisfactorily. After spending about a month in space, astronauts start losing quite a lot of skin from the bottoms of their feet, especially those tough calluses they've built up over time. One astronaut even called mission control in a bit of a panic when he noticed a chunk of his heel drifting off in zero gravity. But no worries, as the old calluses peel away, new ones spring up from the tops of their feet. They need that grip to hold on to all the restraints, kind of like airborne trapeze artists. Going number 1 and seeing blood is as scary as it sounds, and yes, in the weightlessness of space, blood doesn't settle in the lower body in the same way it does on Earth. This can lead to some alarming situations on board. Natural urges are universal, regardless of location. There are 2 main reasons why astronauts are unable to use traditional toilets in space. First, water is an extremely valuable resource aboard a spacecraft. Second, there's no gravitational flow of water in space. The drinkable water on a space station is contained in pouches and is used accordingly. In a weightless environment, A specialized device with suction and disposable bags is used for waste collection, with the storage being replaced every 10 days. Additionally, spacecraft are equipped with complex systems designed to recycle and filter liquid waste, converting it back into usable water for the astronauts' daily needs. As if that wasn't enough, spending an extended period floating around in space brings another challenge. The body may lose its bursa sacs, those handy little cushions that sit between our hip joints. While this may not pose an immediate issue in the zero-gravity environment, returning to solid ground can turn the simple act of sitting down, whether in a chair or on a toilet, into a real struggle. The fluid shifts that contribute to blood-related issues don't stop there. They can also wreak havoc on astronauts' sinuses, creating a constant feeling of congestion. It feels like living in a stuffy room all the time, where relief seems just out of reach. Thus, the challenges of long-term space travel add up, making the experience as daunting as it is thrilling. Another challenge astronauts run into is vision loss, also known as ocular syndrome, which sounds all sciencey. While the exact cause is still a bit of a mystery, it's thought that extra pressure on the brain can mess with both the retinas and optic nerves. And here's a fun fact: it mostly affects guys. By the way, you might assume that shutting your eyes in space means it's pitch black, but that's not the case. Because of high levels of radiation, astronauts can still see bright lights when they zip through certain parts of their orbit. It's a pretty strange phenomenon that keeps them on their toes, even with their eyes closed. Switching gears, let's talk about bone health in space. It turns out that being weightless can really take a toll on astronauts' bones. Like, they can lose up to 2% of their bone mass every month, which is pretty wild. But the good news? They've come up with new exercise routines that help fight off that bone loss. So, while space travel definitely has its challenges, researchers are working hard to keep astronauts in tip-top shape as they explore the universe. The Big Crunch is a cool theory about how the universe might end, and it's basically the opposite of the Big Bang. So, imagine the universe expanding for ages, but then it hits the brakes and starts collapsing in on itself, maybe even forming a huge black hole. Scientists are looking into this by checking out the universe's density. If it's too dense, such a collapse might really happen. At first, people thought that gravity would eventually take over and stop the expansion from the Big Bang. But then we found this mysterious thing called dark energy, which is actually speeding up the universe's expansion. Because of that, it seems like the Big Crunch is pretty unlikely. Right now, the evidence shows that dark energy is here to stay, so the universe will just keep on expanding forever.
Our Sun is an average-sized star, and still, it could fit 1,300,000 Earths. The star is also 333,000 times as heavy as our planet. NASA has translated radio waves created by planets' atmospheres into audible sounds. That's how astronomers found out that Neptune sounds like ocean waves, Jupiter like being underwater, and Saturn's voice resembles background music to a horror movie. Here on Earth, it's bebop jazz. No, I made that up. The sun's surface is scorching hot, but a bolt of lightning is 5 times hotter. Earth gets struck by 100 lightning bolts every second, which results in 8 million lightning strikes a day and around 3 billion a year. Ooh, shocking. If you manage to go to the moon one day and see fresh footprints, that doesn't mean there's someone else there with you. Footprints or similar marks can last for 1 million years over there. Because the moon doesn't have an atmosphere, there are no winds, not even a breeze, that can slowly erase those footprints. Astronomers have found the largest hole we've ever seen in the universe. It's the giant void that spreads 1 billion light-years across. They found it accidentally. One of the research team members was a little bored and wanted to check how things are going in the direction of the cold spot. That's an anomaly in the Cosmic Microwave Background Map, or CMB for short, It's a faint glow of light that falls on our planet from different directions and fills the universe. It's been streaming through space for almost 14 billion years as the afterglow that occurred after the Big Bang. So you fall right into the heart of the black hole and prepare for a sad end. Well, you don't have to. Falling into a black hole won't necessarily destroy you or your spaceship. You have to choose a bigger black hole to survive. If you fall into a small black hole, its event horizon is too narrow, and the gravity increases every inch down. So if you extend your arm forward, the gravity on your fingers is much stronger than on your elbow. This will make your hand lengthen, and you'll feel some discomfort. Rather significant, to be honest. Things change if you fall into a supermassive black hole, like the ones in the center of galaxies. They can be millions of times heavier than the Sun. Their event horizon is wide, and the gravity doesn't change as quickly. So, the force you'll feel at your heels and at the top of your head will be about the same. And you can go all the way to the heart of the black hole. This myth is busted. If you watch a very touching movie in space and start crying, your tears won't run down. They will gather around the eyeballs. Your eyes will get too dry, so you'll feel like they're burning. Any exposed liquid on your body will vaporize, including the surfaces of your tongue. Speaking of burning, that's one thing fire can't do in space. Fire can spread when there's a flow of oxygen, and since there's not any in space, well. Once they explode, stars aren't supposed to come back to life. But some of the stars somehow has survived the great supernova explosion. Such zombie stars are pretty rare. Scientists found a really big one called LP 40-365. It's a partially burned white dwarf. A white dwarf is a star that burned up all of the hydrogen, and that hydrogen was previously its nuclear fuel. In this case, the final explosion was maybe weaker than it usually is, not powerful enough to destroy the entire star. It's like a star wanted to explode but didn't make it, which is why part of the matter still survived. If you ever go into space, don't take off your spacesuit unless you're on a spaceship. Air in your lungs would expand, as well as the oxygen in the rest of your body. You'd be like a balloon, twice your regular size. Good news, the skin is elastic enough to hold you together, which means you wouldn't explode. Small comfort. When something goes into a black hole, it changes shape and gets stretched out just like spaghetti. This happens because gravitational force is trying to stretch an object in one direction, but at the same time squeeze it into another, like a pasta paradox. Speaking of, a black hole that's as big as a single atom has the mass of a really big mountain. There's one at the center of the Milky Way called Sagittarius A. It has a mass like for a billion suns, but luckily it's far away from us. If you made a big boom on an asteroid, you'd never be able to hear its loud sound. Yes, we often hear the sound of spaceships and battles in space in the movies, but that's just a myth. Sound is a wave that spreads because of the vibrations of molecules. A person claps a few feet away from you, the sound wave begins to push the first air molecule next to the clap, then the second, third, and so on, until the wave reaches your ear. So, to spread sound, we need molecules like air or water. In our atmosphere, sound waves spread out just fine, but space is a vacuum, so it's nothing here. You can clap your hands loudly there, but there just won't be any molecules that can vibrate and carry that sound. So, to carry on a conversation, you'd either need a radio or really good lip-reading skills. Meteoroids orbit the Sun, while the majority of human-made debris orbits our planet. For example, we launched almost 9,000 spacecraft around the world from satellites to rocket ships. Even the tiniest pieces can damage a spacecraft at such high speeds. Galaxies, planets, comets, asteroids, stars, space bodies are things we can actually see in space. But they make up less than 5% of the total universe. Dark matter, one of the biggest mysteries in space, is the name we use for all the mass in the universe that's still invisible to us. And there's a lot of it. It may even make 25% of the universe. Dark energy makes the other 70% of the universe. That adds up to 100, right? Now, let's look at the moon. It always looks at us with one side. This means the moon has a dark side and the sun's rays never get there. Well, that's a myth. The whole point is that the moon is gravitationally locked to the Earth. There are days and nights there, too. It's just that this rotation is perfectly aligned with the rotation of the Earth. So whenever you look at the moon, you only see one side. Although there are days when the sun shines there too, so it's not the dark side, it's the far side. And we even have pictures of this place. And there's one of the biggest craters in our entire solar system, the South Pole Aitken Basin. It's as wide as 2 states of Texas. Yeehaw! One myth that turned out to be untrue is that people have never actually been on the moon. This is the original spacesuit of the first astronauts who were there. Look at the sole of the shoe. Some people claim there's no way they could have left footprints like this there. Actually, they could. On the moon, the astronauts wore extra boots over their suits, and their soles matched the footprints on the moon perfectly. Now, the astronauts didn't need them when they left the moon and tossed them when the moonwalk was over. They left a lot of stuff there, too. They even tossed the armrests of the seats in the lunar module to reduce the weight. Now, counting all the Apollo lunar missions, the total weight of rubbish on the moon is approximately 187 tons, including several lunar rovers, spacecraft debris, 6 lunar modules, and all the experiments left behind. That's like 3 Boeing 737s. Another myth about the sun is that it's yellow. Let's send you into space for this one. You look out the window and it's white. The sun only appears yellow to us through the filter of our atmosphere. The composition of the air and its thickness just distorts the light of the star. But stars do come in different colors. Cooler stars have bright orange and red colors. These are usually very old stars, older than our sun. But young and very hot stars are bright blue. The sun is about in the middle of this spectrum. Oh, one more myth about asteroids. We need to fly a little farther than Mars's orbit. Whoa, we're in an asteroid belt, and we constantly have to dodge giant rocks and blocks of ice. We got in some dense asteroid clouds. Not true. The fact is that space is huge, and the distances are incredible. All the rocks and debris in the asteroid belt are only 4% of the weight of the moon, so there really aren't that many of them there. To understand the dimension of the emptiness in space, look at the collision of 2 galaxies. There are billions of stars in each of them. If we mix them up, it's unlikely there will be any collisions even here. Venus most likely used to be covered with oceans, from 30 to 1,000 feet deep. Also, some water was locked in the soil of the planet. On top of that, Venus had stable temperatures of 68 to 122 degrees Fahrenheit, which, you have to admit, was quite pleasant and not that different from the temperatures on Earth nowadays. So, what I'm getting at is that for 3 billion years, right until something irrevocable happened 700 million years ago, Venus could have been habitable. But now it's not. The moon is the second brightest object in our sky. At the same time, among other astronomical bodies, it's one of the dimmest and least reflective. Our natural satellite only seems bright because it's so close to Earth. For comparison, our planet looks much brighter when you look at it from space. It's because clouds, ice, and snow reflect way more light than most types of rock. Triton, Neptune's moon, has all its surface covered with several layers of ice. If this satellite replaced our current moon, the night sky would get 7 times brighter. Neutron stars are some of the smallest yet most massive objects in space. They're usually about 12 miles in diameter, but are several times heavier than the Sun. Oh, and they also spin about 600 times per second, far faster than your average figure skater. Saturn is the least dense planet in the solar system. It has 1/8 the average Earth's density. And still, because of its large volume, the planet is 95 times more massive than Earth. A transient lunar phenomenon is one of the most enigmatic things happening on the moon. It's a short-lived light, color, or some other change on the satellite surface. Most commonly, it's random flashes of light. Astronomers have been observing this phenomenon since the 1950s. They've noticed that the flashes occur randomly. Sometimes they can happen several times a week. After that, they disappear for several months. Some of them don't last longer than a couple of minutes, but there have been those that continued for hours. The year was 1969, one day before Apollo 11 landed on the moon. One of the mission participants noticed that one part of the lunar surface was more illuminated than the surrounding landscape. It looked as if that area had a kind of fluorescence to it. Unfortunately, it's still unclear if this phenomenon was connected with the mysterious lunar flashes. Trash isn't just a problem in Earth's oceans, cities, and forests. There is a thing called space junk, which is any human-made object that's been left in space and now serves no purpose. There's also natural debris from meteoroids and other cosmic objects. There are currently over 500,000 pieces of space debris orbiting the Earth at speeds high enough to cause significant damage if they were to collide with a spacecraft or satellite. NASA does its best to track every single object to ensure that missions outside Earth can reach their destination safely. Our Sun is insanely massive. Want some proof? 99.86% of all the mass in the solar system is the mass of the Sun. In particular, the hydrogen and helium it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. The Sun's temperature is hotter than the surface of a star. The surface temperature reaches 10,000 degrees Fahrenheit, but the upper atmosphere heats up to millions of degrees. If someone could dig a tunnel straight into the center of the planet and out the opposite side, and you were adventurous enough to jump into it, it would take you 42 minutes to fall to the other side. You'd speed up as you fell, reaching maximum speed by the time you reached Earth's core. After the halfway point, you would then fall upwards, getting slower and slower. By the time you reached the opposite surface, your speed would be back to zero. Unless you managed to climb out of the hole, you'd immediately start falling again, back down or up to the other side of the planet. This trip would go on forever, all thanks to the weird effects of gravity. Hey, might be a fun way to spend an afternoon. There might be more metals, for example, titanium or iron, in lunar craters than astronomers used to think. The main problem with this finding? It contradicts the main theory about how the moon was formed. That theory says that Earth's natural satellite was spun off from our planet after a collision with a massive space object. But then, why does Earth's metal-poor crust have much less iron oxide than the Moon's? It might mean the Moon was formed from the material lying much deeper inside our planet. Or these metals could have appeared when the molten lunar surface was slowly cooling down. Or maybe, as they've been saying for centuries, it's made of green cheese. Earth could have been purple before it turned blue and green. One scientist has a theory that a substance existed in ancient microbes before chlorophyll. That thing that makes plants green evolved on Earth. This substance reflected sunlight in red and violet colors, which combined to make purple. If true, the young Earth may have been teeming with strange purple-colored critters before all the green stuff appeared. The highest mountain in the solar system is Olympus Mons on Mars. It's 3 times as high as Mount Everest, the Earth's highest mountain above sea level. If you were standing on top of Olympus Mons, you wouldn't understand you were standing on a mountain. Its slopes would be hidden by the planet's curvature. Astronomers have found a massive reservoir of water in space, the largest ever detected. Too bad it's also the farthest, 12 billion light-years away from us. The water vapor cloud holds 140 trillion times as much water as all the Earth's oceans combined. What are we supposed to do with that information? Venus spins at its own unhurried pace. A full rotation takes 243 Earth days, and it takes the planet a bit less than 225 Earth days to go all the way around the Sun. It means a day on Venus is longer than a year. There's very little seismic activity going on inside the Moon. Yet many moonquakes, caused by our planet's gravitational pull, sometimes happen several miles below the surface. After that, tiny cracks and fissures appear in the satellite surface, and gases escape through them. Hey, they sometimes escape from me, too. Now, Mars is the last of the inner planets. which are also called terrestrial since they're made up of rocks and metals. The red planet has a core made mostly of iron, nickel, and sulfur. It's between 900 and 1200 miles across. The core doesn't move. That's why Mars lacks a planet-wide magnetic field. The weak magnetic field it has is just 1/100th% of the Earth's. When the planets in the solar system were just starting to form, Earth didn't have a moon for the longest time. It took 100 million years for our natural satellite to appear. There are several theories as to how the moon came into existence, but the prevailing one is the fission theory. Somebody went fishing and caught the moon? Actually, no. The fission theory proposes that the moon was formed when an object collided with Earth, sending particles flying above. Gravity pulled the particles together, and the moon was created. It eventually settled down on the Earth's ecliptic plane, which is the path that the moon orbits. So, looks like the green cheese is off the table now. The largest single living thing on Earth turns out to be a mushroom in Oregon. This enormous honey mushroom lives in Malheur National Forest and covers an area of 3.7 square miles. It could be as much as 8,500 years old. You could be forgiven for missing it, though, since most of it's hidden underground. When the roots of individual honey mushrooms meet, they can fuse together to become a single fungus, which explains how this one got so big. If you could gather all that mushrooming stuff into one big ball, it could weigh as much as 35,000 tons. That's about as heavy as 200 gray whales. Hey, that's a whale of a mushroom. Hehe. The largest asteroid in the solar system is called Vesta, and it's so big that it's sometimes even called a dwarf planet. A trip to the nearest star, apart from the Sun, would take you 5 million years on a commercial airplane. That's what I call a long-haul flight. Space isn't supposed to be black. There are stars everywhere. Shouldn't they light up everything around? Well, you don't see stars wherever you look because some of them haven't existed long enough for their light to reach Earth. A day on Uranus lasts 17 hours, 14 minutes, and 24 seconds. But get this, the planet has a tilt of around 98 degrees, and that makes a season on the gas giant last 21 Earth years. Now, some scientists believe that our planet used to have an additional satellite. According to their research, a small celestial body, about 750 miles wide, orbited Earth like a second moon. It most likely crashed into our main satellite later on. Such a collision could explain why the two sides of the moon look so different from each other, one being heavily cratered and rough. Or it could be the green cheese.
The sun's heat is beneath our feet. Scientists have figured out that Earth's core is actually as hot as the surface of the sun, around 10,800 degrees Fahrenheit. One of the reasons it's so incredibly hot down there is because Earth is still shedding heat from when it was created billions of years ago. Also, when an object as big as Mars slammed into the young Earth, it not only created the moon, according to one theory, but melted the surface of the planet. A lot of that extra heat is probably still stored inside the core. But there's no need to worry. The planet's core is harder for us to access than it is to probe the surface of Pluto. In fact, chances are we may never develop technology that could physically reach the core. There's no air on the moon. But then, how can it be rusting? Scientists have discovered the presence of hematite on the moon, and it's a kind of rust. A special NASA research instrument examined the light reflected off the moon's surface. It turned out that the composition of the satellite's poles was very different from the rest of it. The moon's surface is dotted with iron-rich rocks, but without oxygen and liquid water, rust can't appear. Solar winds add to the mystery. They bombard the moon with hydrogen, and hydrogen makes it much more difficult for hematite to form. Even though the moon doesn't have an atmosphere, it still has some trace amounts of oxygen. Its source is our planet's upper atmosphere. Earth also protects the moon from almost 100% of solar winds, although not all the time. And even though our natural satellite is bone dry, there might be water ice in the shadowed craters on its far side. A day on Uranus lasts 17 hours, 14 minutes, and 24 seconds. But get this, the planet has a tilt of around 98 degrees, and that makes a season on the gas giant last 21 Earth years. Mars has 2 moons, Phobos and Deimos. In the next 30 to 50 million years, Mars's gravitational forces will tear Phobos apart, and it will likely result in the formation of a ring around the planet. The Earth is the densest in the solar system. At the Earth's center, there's a core that takes up 15% of the planet's volume. It consists of 2 parts, the outer and the inner core. The inner core is a solid ball made of iron and nickel. Its radius is 760 miles, which makes 20% of the entire Earth's radius and 80% of the Moon's radius. The 1,500-mile thick outer core is liquid. It also consists of iron and nickel, but it's not under enough pressure to be solid. Mars houses the biggest volcano in the solar system. While everything seems to be calm on Mars nowadays, in the past, some sort of force caused enormous volcanoes to form and erupt. One of these volcanoes is Olympus Mons. It's 16 miles tall, which is the height of 3 Mount Everests, and 374 miles across, making it about the size of Arizona. The volcano grew to such a gargantuan size because of the weak gravity on Mars and the lack of tectonic plate movement. Gravity is not the same everywhere. The rocks, metals, and other minerals and substances that make up the planet are packed into the ground more tightly in certain places than in others. This has surprising consequences. Gravity varies slightly depending on where you are. You weigh 0.5% less standing at the equator than you do at the poles. In most cases, that's a difference of less than 1 pound. How high up you are also has an effect. So if you were at the top of Mount Everest, you'd also weigh slightly less. Just don't look down. Earth's toughest living thing is so small you can't see it. Water bears, also known as moss piglets, are cute little creatures with 8 legs and squashed up heads that are less than 1/100th of an inch in length. Despite their microscopic stature, they can basically survive anywhere. They prefer bits of wet moss or the bottom of a lake, but they won't complain if you put them somewhere really uncomfortable. They can endure extreme cold and incredible heat, and survive both huge pressure and high radiation. Some of the little bears once even managed to survive unprotected in outer space for 10 days without a problem. That is tough. They handle all these things by rolling up into a ball and hibernating, which reduces their need for oxygen and food. The Moon's gravity is about 17% of that on Earth. If you weighed 200 pounds on our home planet, on the Moon, your weight would decrease to a mere 34 pounds. You would also be able to carry stuff 6 times heavier than what you can carry on Earth. It would also be easier to walk on the Moon's surface, but it would be more dangerous too. Your feet, inside a heavy spacesuit, would sink into the lunar soil up to 6 inches deep. But let's imagine you decided to skip the tedious process of walking by leaping through the air. Then you'd likely lose control of your jumps in no time. Plus, the Moon's surface is littered with deep craters. It would be a tough feat to avoid all of them. You can see solar eclipses because even though the Moon is 400 times smaller than the Sun, it's also 400 times closer to Earth. So it's perfectly capable of obscuring the star. But in 50 million years, I won't be around then. The Moon won't be able to block the Sun completely because of the satellite's changing orbit. A full NASA spacesuit costs an unbelievable $12 million. Yeah, I can believe that. 70% of this hefty sum is for the control module and backpack. At the very center of Uranus, there's a rocky core, small, just half the Earth's mass. Compared to other planets, Uranus's core is rather cool, 9,000 degrees Fahrenheit. An ice mantle surrounds the solid core, and that's the largest portion of the planet, about 80%. It's also not the ice you might be thinking about. It's a hot, dense fluid made up of water, ammonia, ice, and methane. sometimes referred to as a water-ammonia ocean. Uranus's atmosphere is mostly hydrogen and helium, but it has its blue-green color because of methane gas that absorbs the red light. The ocean on Jupiter is larger than any other in the solar system. But unlike Earth's oceans, it's made not of water, but of metallic hydrogen. The ocean's depth is a mind-blowing 25,000 miles. That's almost the same as the distance around Earth. Venus is a champ when it comes to volcanoes. The planet has about 1,600 major ones, but none of them is known to erupt. There's a supermassive black hole 250 million light-years away from us. It hums the deepest sound ever detected from any object in the universe. It's 57 octaves lower than the middle C on your piano. That's 1 quadrillion times deeper than what we can hear. Mercury is a few billion years old. In 2016, scientists discovered some abnormalities on the planet's surface, showing that it's getting smaller. After more research, they found out that Mercury hadn't finished cooling down yet. There are planets that aren't bound to any star orbit and aimlessly wander through outer space. Among the most spectacular-looking space objects are pulsars. Pulsars are a type of neutron star. They shoot out some of their material almost at the speed of light. Regular pulsars spin at a reasonable speed, between 1/10 to 60 times per second. But millisecond pulsars can spin at an impressive 700 times a second, which is way too fast for the human eye to even process. As they spin, they emit a beam of radiation from their axis that looks like the light from a lighthouse. Astronomers can notice pulsars when they face Earth, since it looks like a light being shined on our planet. When the light shines elsewhere, the pulsar can't be seen. Our sun is insanely massive. Want some proof? 99.86% of all the mass in the solar system is the mass of the sun. In particular, the hydrogen and helium it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. Saturn's rings are very thin compared to its size. If you had a scale model of the planet that was 3 feet wide, the rings would be 10,000 times thinner than a razor blade. Even though Venus is the hottest planet in our solar system, it still has snow. But not what you'd expect. It snows metals and rains acid. Not a great vacation spot. You're sitting at a coffee shop on Mars, keeping your head down, trying not to draw any attention to yourself. It's crowded, and many people are singing, dancing, and talking loudly about life on Mars. Your drink arrives, and you sip on it. So far, no one recognizes you. You're wearing a cloak with a large hoodie to cover your face and disguise yourself from everyone. Someone accidentally bumps into you and sees your face. The music stops, and now everyone is staring at you. You have nowhere to hide or run. You ignore the leering eyes and keep sipping on your beverage. An old bearded man sits in front of you, amazed to be in your presence.
"So, it's true. No one believed you'd make it,"
he says. You don't reply and continue with your drink. Everyone else gathers around you. Another man speaks.
"Well, are you not going to tell us how you escaped from the clutches of the space kraken?"
Everyone gasps in shock. No one has ever made it to tell the tale of the Kraken, except you. Your plan was to find your messenger to take you to a spaceship far away from this planet. But it's too late, now that everyone knows you're here. And the messenger fled, knowing all the attention was on you. You lay back your hoodie and explain what happened. 2 days ago. You're in your full gear, ready to make the voyage into deep space. You have a solo ship that's designed to maneuver through all the obstacles in space. You prepare the rest of the gear and fuel up. Everyone is watching you, knowing that you might not make it back. But the Kraken has been floating in space for too long, disrupting shipping containers bringing in goods. A small ship like yours can sneak past its acute sense of smell and vision. but larger ships will get destroyed. You made it your mission to find this Kraken and study it. If you learn its ways and patterns, you can figure out how to get rid of it. Everyone says their goodbyes, and you lift off. You know that it'll be a very long way to get there, possibly 3 days in the emptiness of space. You saw some quick footage of it, but no one knows exactly where it sleeps, or if it even does sleep. You put on some tunes and set your ship for cruise control. You make some notes and set the camera to document yourself while you prepare everything you need. You also have some cameras outside recording everything that moves, even thermal sensors to catch living creatures floating in space. After a few hours, you exit the safe quarters of Mars and enter into the hostile territory. There is no place to hide or anyone to help you. A few little ships like yours pass by now and then. They watch you going further to the Kraken. You notice many floating signs powered by machines warning you about the Kraken. The cameras start recording, and you begin your video journal, which is transmitting to your network at home. So far, nothing. It's quiet and dark. Hours pass, and you're just floating in the middle of nowhere. You almost feel like you want to turn around, but then you pick up something in the sensors. You see a large live object nearby. You turn off the lights and slow down your ship. You resume recording and start talking to yourself, explaining everything. The object is getting closer and closer. You move aside to avoid it and latch on to a floating rock, but you still don't see anything. Out of nowhere, you see some glowing jellyfish-like creatures flowing together in a cluster. On your thermal sensors, they appear to be large objects, but in fact, they are just little creatures. According to your studies, these creatures are some of the main foods for the Kraken, so they're probably running away from it. After a few minutes, the creatures float away, and you launch yourself out and turn the lights back on. A few more hours pass, and you still see no Kraken. Suddenly, a whoosh shakes your ship, and you're thrown slightly off course. You notice that a large object has spiked your thermal sensors and left. You keep going and check the playback settings to see if your cameras manage to catch something. You try to look carefully, but it seems like a gust of wind blew past you, which is weird because there is no wind in space. You check the thermal sensors and notice that a large object shaped like the Kraken has zipped past you. It's still around, and it has probably caught your scent. Your system's got some DNA particles and are studying them. After a while, they show that the Kraken's skin can change colors according to its surrounding. Its skin is thick and made up of some cosmic fluorescent material that is new to any creature you've ever come across. The system continues studying it. After a while, the Kraken goes off your radar and disappears. You circle back, trying to find it. People back on Mars can see the data and already have information about its size and skin quality. They even see some footage you've managed to catch. As you continue driving towards it, you open your floodlights, trying to see anything. Your cameras are still rolling. Suddenly, the Kraken changes skin color and appears right in front of you. Its large tentacles flash around, whipping nearby space debris. Its large eye, that's as big as a bus, looks right at you. It opens its mouth, and you see layers of sharp teeth circling like a grinder. It has a large beak that can break your ship easily. It starts flashing its colors rapidly as a way to warn you. It shoots out some liquid to move in a no-gravity space environment. It's moving towards you until it launches itself. Your ship has an auto force field for protection, but it can't sustain the powerful bite of the Kraken. After only a few seconds, the shield breaks, and your ship spirals down to another planet. You crash-landed in a swampy land. Your ship has survived, but it can't take off. The analysis of the Kraken is ready. It shows that it doesn't need oxygen to breathe, and its DNA is evolving. Now that it got a bite of your force field, it can adapt itself to create a bioforce field of a similar nature. But you crashed on a planet that is foreign to you. You put on your safety suit and observe the environment. The atmosphere is filled with nitrogen and sulfur. You get out and walk around. It has similar gravity to that of Earth. As you venture through the swamp, You start seeing little skin particles similar to those your ship has caught. The liquid below you is some foreign substance that seems to be deteriorating your suit, so you opt to hover. The trees are strange and seem to be living off the atmosphere, but there is no sign of life anywhere. Suddenly, you see a huge crater that leads to the center of the planet. You enter it and see some ships similar to yours. It seems that the Kraken knocked them off course, and they all crash-landed on this planet. Many of them seem to be intact, while others are completely obliterated. Your sensors pick up another reading. It senses another creature dwelling in the center. You try to get closer. You're doing your best to be as gentle as possible, but you feel the ground shaking below you. You duck down and try to avoid the rocks falling overhead. A large tentacle pops out of nowhere, and then another and another. It swings itself out and crawls in the open. According to your system's studies, this Kraken is 10 times larger and even looks different. It doesn't spot you, but it can sense that you're around. It starts thrashing the planet, trying to find you. It knocks your ship. You try to find a way to start it, but it's missing a piece. You find another abandoned ship and take out the part that you need and put it on your ship. Your suit has an auto repair function that allows you to fix your ship without the tools. After a few minutes, it's ready for takeoff. You power up your ship, even though it's damaged, and lift off. You manage to sneak past the Kraken. Everyone at the coffee shop is silent. Many don't believe your stories. They had stopped receiving live transmissions before you were knocked off by the space Kraken. Out of nowhere, an alarm rings and warns that the Kraken has arrived. Everyone rushes off in a panic. You hear a voice in your head. It's a bunch of gibberish, but you start getting visions of the Kraken talking to you. It knows you're here, and it's coming for you.
At a distance of 640 light-years from the Sun, scientists discovered planet WASP 76b, where it rains iron. The planet is very close to its Sun and always turn to it in the same side. The term is tidally locked. The temperature on the sunny side is so high that metals melt and evaporate there. The other half of the planet is cool enough so that metals condense again and fall down as rain. Speaking of tidal locks, our moon is the same way. There's no dark side to our satellite, it's just always turned to us with one side. When the moon happens to be in between the Earth and the Sun, what we call its dark side becomes brightly lit. We just can't see it from our planet. Figures. A recent study claims that the moon has a tail, and every month it wraps around our planet like a scarf. A slender tail made up of millions of atoms of sodium follows Earth's natural satellite, and our planet regularly travels directly through it. Meteor strikes blast these sodium atoms out of the moon's surface and further into space. You won't believe it, but the moon seems to be shrinking. Earth's natural satellite is now 150 feet smaller than it used to be hundreds of millions of years ago. The reason for this phenomenon might be the cooling of the moon's insides. It could also explain the quakes shaking the surface of our planet's natural satellite. Astronomers have recently found out that Mars is seismically active. Mars quakes occur there on a regular basis. For several days every month, the moon remains between the Sun and our planet. That's when Earth's gravity picks up that sodium tail. Our planet drags it into a long stripe that wraps around its atmosphere. This lunar tail is totally harmless. It's also invisible to the human eye, 50 times dimmer than what you can perceive. But on those rare days, high-powered telescopes can spot its faint yellowish glow in the sky. The tail looks like a gleaming spot that's 5 times the moon's full diameter. Turns out there are plenty of planets in the universe, and even in the Milky Way galaxy, that have liquid or frozen water on them. The closest one is within our solar system. It's Europa, one of Jupiter's moons. Scientists are almost sure that underneath its frozen surface there's an actual ocean of water. But it's too soon to be hyped about possible life on such planets. Liquid water is only one of many things that have to come together for life to appear on a planet. A star in the galaxy GSN 069 is likely to turn into a planet the size of Jupiter in the next trillion years. It might happen because of the star's regular encounters with a black hole. First, astronomers noticed unusual X-ray bursts that were strangely bright. They went off every 9 hours. After studying this phenomenon for some time, the scientists realized it was a star moving in a unique orbit around a black hole. The dazzling flashes? It was the material getting slurped off the star's surface by the black hole. It turned out that over millions of years, the black hole had already transformed the red giant into a white dwarf, and the process isn't going to stop whatsoever. Astronomers have found some traces of phosphine in the atmosphere of Venus. On our planet, this gas, colorless and flammable, is often found where microbes live. No wonder a new theory suggests that there might be life on Venus. But even if there was some life on the evening star, it could have only appeared in its atmosphere. Probably no living organism would be able to survive the planet's extreme environment. Venus's surface is extremely dry. There's no liquid water on the planet, and the pressure there is 90 times greater than that on Earth's surface. The temperatures often rise higher than 900 degrees. That's hot enough to melt some metals. As for vacations there, I'll pass. In fact, there's a place millions of light years away where there's a whole floating space cloud made entirely of water. There's so much of it that we could fill all our oceans 140 trillion times over. Slightly more than what we need. Water on Earth is actually a puzzle shrouded in mystery and covered with riddles. The most popular theory is that it was brought to our planet by icy comets and asteroids that left behind not only mighty craters, but the liquid substance thanks to which we can now thrive. But in space, there's a whole lot of organic matter, and under specific conditions, it could yield so much water it would be enough to fill our oceans thousands of times over. Researchers conducted an experiment in which they heated this organic matter and obtained clear water and oil. If this is confirmed in future studies, it could mean that even oil appeared on Earth not only thanks to fossilized remains of living beings, but came from outer space as well. And yet, there might just be about 6 billion Earth-like planets in the Milky Way galaxy alone. The latest data has shown that every fifth Sun-like star can have at least one planet in its habitable zone. And not just any planet, mind you. It has a rocky core and surface, and it's of comparable size to the Earth. Being inside the habitable zone of its star, such a planet would have high chances of becoming home to living creatures, microbes at least. And if there are billions of these planets in our galaxy, you could safely say that at least one of them is not only habitable, but inhabited already. And now, multiply this by the number of galaxies in the universe, also considering that many of them are much bigger than the Milky Way. This gives us billions upon billions of Sun-like stars and Earth-like planets, and some of them are surely more like ours than others. And get this, we might be able to walk upright because of supernova explosions. About 2.5 million years ago, a supernova sent cosmic rays to our planet. They triggered a series of electrical storms in the Earth's atmosphere, which turned into thunderstorms. Those in turn caused wildfires in Northeast Africa, where our earlier ancestors lived. Fires turned the forest area into a savanna, the atmospheric pressure changed, and our ancestors had to stand on two legs to survive. The biggest explosion since the Big Bang was registered in 2019. This happened in the Ophiuchus cluster, which unites thousands of galaxies. According to scientists, the blast was equal to 20 billion, that's 18 zeros, megaton explosions happening once a millisecond for 240 million years. I'll have to trust that. My math is not that good. In 2019, NASA's InSight lander, whose goal was to study the interior of Mars, registered the first Marsquake ever. These quakes were coming fast, about 2 per day. Most of them were tiny. You wouldn't even feel them if they happened on our planet. So far, more than 300 Marsquakes have been detected. Those are the first quakes on any space body other than Earth and the Moon. Another mysterious phenomenon discovered by the mission was bizarre magnetic pulses. They occurred every midnight around the lander. It's still unclear what those pulses were. Maybe after midnight they're going to let it all hang out, or something. Pluto's atmosphere rises much higher above the surface of the dwarf planet than, let's say, Earth's. It also has more than 20 layers, all of them freezing cold and extremely condensed. Remember the asteroid that wiped out the dinosaurs on Earth? Hey, I wasn't around then, but who could forget? There might have been another space show that ended badly for at least 75% of all life on our planet in the past. Roughly 360 million years ago, a supernova explosion occurred about 65 light-years away from us, and the cosmic rays sent by it swept away the ozone layer of our pretty blue ball. Wow, tough neighborhood.
Did you know that humans are real space people? You were born in space. Heck, even I was born in space. We were all born in space. But for humans to be here on Earth, so many conditions have to be precisely correct that it's highly improbable that we even exist. But we do. First, we, and any other space creatures who might be out there, have to live on a planet orbiting a yellowish white star, not a red star or a blue star. Not a blue star, because they burn out too quickly. In a few million years, there wouldn't be time for evolution to do its relatively slow magic and produce intelligent beings. Blue stars also tend to swell up and turn red. When they collapse and explode, it makes it highly unlikely that any civilization could prosper near a blue star. Red stars, which are by far the most numerous kind of stars, don't seem like good prospects for intelligent civilizations to orbit around either. Red stars are so cold and so dim that a planet that could grow a civilization must orbit very closely to the red star, which would expose the planet to intense, deadly X-ray radiation. So, though red stars are the most numerous and appear to have many planets orbiting them, red stars are a no-go for hosting intelligent, civilized life like our own. That leaves the yellowish stars, about 10% of all stars. However, an important fact must be met before considering the possibility of intelligent life living around a yellowish star. That fact is that the yellow star must be a third-generation star. Only third-generation stars will contain sufficient chemical diversity to sustain advanced life forms. Each time a star explodes, heavier, more complicated elements are created. The explosion expelled these elements and eventually found their way into a nebula. Gravity within the nebula will gradually form the next generation of stars, and so on. Our bodies need calcium for our skeletons and teeth. Our brains need zinc to help create the electrochemical signals that make us move, feel, and think. Our blood needs iron. Therefore, our bodies need to have formed around a third-generation star, and a yellow one. Amazingly, Earth has all the different elements in the universe, all 94 naturally occurring ones, from hydrogen to plutonium. Maybe that's why we're here. And we have to thank our third-generation yellow dwarf sun for that. Why yellow? Because yellow stars burn very steadily by nuclear fusion, without significantly changing brightness over billions of years. If our sun became just 6% brighter or dimmer, Earth would become too hot or too cold to sustain civilized life. Fortunately, Earth is in the habitable zone around the sun. The habitable zone is where liquid water can exist on a planet. But that brings us to the second condition necessary for intelligent life to live in space: the planet itself. Recent studies with the Kepler telescope have shown that 1/4 of all yellow dwarf stars may contain Earth-like planets in the habitable zone around yellow dwarf stars. That figure is somewhat debatable. It might be as few as 1 out of every 33 yellow dwarf stars, but that's still a lot of planets orbiting yellow stars in habitable zones. So let's consider the second essential component for intelligent life in space: the planet itself. The planet that would bear intelligent civilization must have many particular characteristics that aren't easy to come by individually, and even more rare to find in combination. Most importantly, the planet must have protection against the star it's orbiting. Because stars shine by nuclear fusion in their cores, gas in the outer shell of the sun, called the corona, gets blown off into space in what's called the solar wind. Our United States satellites take constant readings of the force of the solar wind, which is mainly electrified, ionized, hydrogen nuclei, along with a smattering of atomic nuclei from the many other elements found in the sun. It's not the atmosphere that protects Earth, it's the magnetosphere that stops or deflects the dangerous solar wind, causing aurorae when the solar wind is attracted to Earth's magnetic poles and electrifies the air of the upper atmosphere like a fluorescent bulb. Without a magnetosphere surrounding it, any planet, even those in habitable zones, would be toasted by a constant rain of ionized hydrogen nuclei from its star. A planet with life on it must have a magnetosphere strong enough to deflect the solar wind. Not every planet in our solar system has a magnetosphere. The gas giant planets, Jupiter, Saturn, Uranus, and Neptune, have magnetospheres, but gas planets cannot have civilizations. Of the solid worlds, only Earth and Mercury have magnetospheres, and Mercury is too weak to stop the solar wind because of its closeness to the Sun. Another protective shield that keeps the Earth safe from the Sun is its atmosphere. The atmosphere is about 300 miles thick, with most of it concentrated within just 10 miles of the Earth's surface. The atmosphere protects life on Earth from both the Sun's ultraviolet, UV, radiation, and X-rays. The gas, ozone, which is 3 oxygen atoms bound into a large gas molecule in the upper atmosphere, blocks most of the Sun's UV radiation from reaching the ground. The planet Mars, whose atmosphere is 1,000 times thinner than the Earth's, has no ozone, and the Sun's ultraviolet emissions have totally irradiated its surface. A planet must be able to stop the UV radiation from its star, so the specific composition of the atmosphere is critical for any planet to have an intelligent civilization. We've got it, but it is a rare and precarious mix. The planet must have some part of its surface solid to walk and work on. The planet must have a crust. It's pure science fiction to consider underwater civilizations or floating civilizations in the atmospheres of other planets. A planet's crust must have tectonic plates that move. This movement of tectonic plates creates the subduction of the crust. Subduction is when one tectonic plate slides under or over another, bringing the fresh matter to the surface. This renewal of the chemical properties of the planet prevents chemical equilibrium, where nothing is reactive. Earthquakes and volcanoes also contribute to the process of geochemical renewal. That's right, earthquakes and volcanoes are good. Subduction of tectonic plates, then, is another planetary essential for life. Mars doesn't have tectonic plate activity. Neither does Venus nor Mercury. Mercury is one big tectonic plate, but there's no ongoing plate activity other than slight shrinkage. One big reason these planets have no life is that there's no geochemical reactivity because there's no tectonic subduction. And that brings us to the Moon. Yes, the Moon. To say that the Moon keeps us alive may seem like a stretch, but the contribution of the Moon to life on Earth is essential. First, the gravity of the Moon as it moves through space with the Earth not only makes the ocean tides ebb and flow, it also helps the rotation of the Earth to churn or stir the magma inside the Earth. The motion of the magma inside the Earth, with its high metallic content, contributes to the creation of the Earth's magnetosphere. So, the Moon keeps us safe in space by helping Earth become a geodynamo and creating our magnetism. The Moon is the largest moon in the solar system compared to the size of the planet it orbits. Essentially, it's primary. Many people consider the Earth-Moon system to be a double planet, but that's another issue. Another thing the Moon does that keeps life safe on Earth is to hold the Earth steady. Because the Moon is gravitationally locked to the Earth, the Moon acts much like a balance pole does for a tightrope walker. Therefore, the Earth doesn't wobble very much compared to other planets. This wobble is called libration. If the Earth wobbled as much as Mars or Saturn, not only would our weather become chaotic, but farming might have been impossible. These rare or unique astronomical circumstances work together to make Earth habitable for humanity. Many other factors are not astronomical, such as evolutionary, biological, and chemical factors required for life to exist on Earth. The probabilities, or improbabilities, are multiplying. Taken all together, we are very, very lucky to be here. In fact, we're so lucky that we may have hit the jackpot. Considering all the possibilities, it's doubtful that anywhere else in the universe is as fortunate as Earth.
All aboard! This is the Intergalactic Cruiser. The destination on your ticket is a tour of the local group of galaxies, featuring the large and small Magellanic galaxies, the Orion Nebula, the Andromeda and Triangulum galaxies, and a few surprises in between. Tickets, please. Be advised you may experience a slight tingling sensation as we rev into hyperspace. The ship and everything in it is going through a dimensional phase change. It's nothing to worry about. The tingling passes quickly. Now, passengers, as we head toward galactic latitude 180 degrees north, as Terrarians are accustomed to calling it, our first main item of interest will be an intense star-forming region known as M42, the Orion Nebula. But first, a special treat by the captain that's not on the advertised itinerary. The Horsehead Nebula. It's off to the port side. That's left for you Aggies. Its designation is M43. The newborn star at the top of the Horse's Head has a strong solar wind that is deforming the shape of the nebular cloud. Get a good look at it now, because in a few thousand years, those gases will be completely blown away by the star-like nebula that made our sun. Yep, long gone, except for the nebular gases captured by Jupiter, Saturn, Uranus, and Neptune. Okay now, one of our junior explorers asks a question. What is the M in M42 and M43? Well, young lady, the M stands for Messier. Pronounced Messier, not Messier, as in, is your room messier than mine? Charles Messier to be precise, was a French astronomer in the 18th century. He published a catalog of 110 fuzzy objects as seen through an early telescope. The Horsehead Nebula is number 43 on his list. We'll see more M's as we continue our tour. Heads up, we're coming to the Orion Nebula. The gases in the nebula may seem less colorful than you expect. That's because we're accustomed to seeing long-exposure telescopic photos and enhanced photos designed to highlight the different gases in the nebula. May I suggest using the pair of tinted glasses that come with your onboarding packet if you want to heighten your experience. In we go! Now, it's a good thing we are in hyperspace. As we approach the trapezium star cluster in the center, the bright star, Theta C, sends out a solar wind at 5 million miles an hour. It sculpts the whole cloud of gas and dust, creating shock waves that compress nearby stars. Theta C is a megastar, 200,000 times brighter than the Sun. It will go supernova in about 1 million years. I won't be around then. Oxygen, hydrogen, and sulfur glow in ionized states like a fluorescent light bulb. Oxygen blue, hydrogen red, some green and sulfur, and dust glow as yellow-orange. As we pull out of the Orion Nebula and rise high above the galactic plane, the spiral arms of the Milky Way are visible. Our sun, which you cannot distinguish from this height above the galaxy, is in the Orion spur that lies between the outer Perseus arm and the inner Sagittarius arm. Notice the center of the Milky Way contains a bright magnetic bar that plays an essential part in star formation. Over 70% of nearby galaxies include magnetic bars. It's a sign of a mature galaxy. Only 20% of distant galaxies contain magnetic bars in their cores. Which reminds me, passengers, the juice bar is now open. Our H1 server will take your orders. Now, that's the Andromeda Galaxy far, far out to the port side. But may I call your attention to the many dwarf galaxies, over 40 of them, that populate our galactic neighborhood. We're heading to one now. The Large Magellanic Cloud, LMC to astronomers, is an irregular dwarf satellite galaxy of the Milky Way, containing about 30 billion stars with a dynamic star-forming region called the Tarantula Nebula, which we will be cruising through shortly. Of course, if there is a large Magellanic Cloud, there must be a small Magellanic Cloud, SMC. And there it is, below and to the left of the LMC. The Milky Way will eventually ingest both dwarf galaxies. Some prefer the word accreted, but the result is the same. If you use your tinted glasses again, you can see that the LMC has stripped away a tremendous amount of gas from the SMC, as they have interacted gravitationally over millions of years. Hey, I know all about gas. Now we're heading out of the Milky Way to a distance of about 50 kiloparsecs. That's 50,000 parsecs, or about 163,000 light years. So, what's a parsec? No, it's not slang for pair of socks. A parsec is about 3.26 light years. A light year is about 5.88 trillion miles. The word parsec is a combination of two words, parallax and second. Parallax is the shift an object seems to make when viewed from two different perspectives. Looking at an object with your left eye and then your right eye, you'll see the object appear to shift. That's parallax. When an astronomical object is photographed with the Earth on one side of the Sun and then again 6 months later on the other side of the Sun, the shift is measurable in degrees of arc, or minutes of arc, or seconds of arc, down to milliseconds of arc. That's a parsec, a parallax of 1 arc second, which turns out to be 3.26 light years. Hey, what about a Joan of Arc? That's how you measure distances in France. Ha ha! Meanwhile, since you can't measure a light year with a ruler or a tape measure, parsecs are the scientific way of telling the distance to a star or intergalactic object. The greater the parallax, the closer the object is. The smaller the parallax, the farther away it is. Now, straight ahead in the heart of the Tarantula Nebula is the R136 star cluster. Within a distance of 1 light year, there are over 40 stars each with a mass over 50 times that of the Sun. Wow! Comparatively, there isn't a single other star within 4 light years of our home star, Sol, and that's a good thing. You can see supernova 1987A at about 2 o'clock high. A blue giant star, 100,000 times brighter than the Sun, experienced a core implosion, resulting in a Type II supernova 100 million times brighter than the Sun. It has left behind a neutron star, clouded in dust and gas, and a wildly spectacular display of fireworks. Now, 1987A in the Large Magellanic Cloud is the closest supernova to Earth since 1604, which happened in the Milky Way about 20,000 light years from Earth. It was visible in the daytime for about 2 weeks, or so. After 1987A went supernova because it was a blue giant star, speculation has increased that the blue giant star Rigel, the foot star of the constellation Orion, might go supernova in the not-too-distant future, or already has gone supernova. Rigel is approximately 860 light-years from Earth, so anything that happens to Rigel would take about 860 years before it would be noticed on Earth. Supernova 1987A ejected the heavy elements like cobalt, nickel, and iron and lighter silicates into the Tarantula Nebula, where they will form the basic building blocks of stars and planets. Our server is now offering space-themed snacks. May I recommend the Jupiter Cotton Candy Puffs for the children on board? Remember, I know all about gas. Our next stop is the Andromeda Galaxy and environs. Notice its halo as we leave the Milky Way and its 300 billion stars behind. As many as 150 globular clusters reside in the galactic halo. They orbit down and through the galactic disk and contain some of the oldest stars in the universe. How they got here in our home galaxy is a matter of intense study. You will notice NGC 6822, an irregular dwarf galaxy off to the starboard. NGC stands for New General Catalog of Astronomical Objects. Now you'd think there'd have been an old general catalog, but there wasn't. It was just a new catalog. There is, however, a revised new general catalog which astronomers refer to regularly. Clears that up, huh? As we pass NGC 6822, you'll notice a magnetic bar beginning to form and bright patches of new star formation. This galaxy was discovered in 1884 by E. Barnard and is also called Barnard's Galaxy. Mr. Barnard was quite an astronomical observer. He has a crater on the Moon named for him, one on Mars, an area on Jupiter's moon Ganymede, a minor planet, number 819 Bernardiana, and the star with the fastest movement across the sky, Bernard's Star. Now, not too many people have their name emblazoned across space, as has Edward Emerson Bernard. Approaching the giant Andromeda Galaxy with its trillion stars, we will skirt above its western edge and visit one of the enormous galaxy's dwarf companion galaxies, M110 or NGC 205. Yes, it also has 2 designations. Hey, take your pick. The first of its kind, a dwarf spheroidal galaxy of about 3.5 billion solar masses, M110 or NGC 205 if you wish, has 8 globular clusters near its core. It too will be swallowed, or accreted if you prefer, by the Andromeda Galaxy. It may have already been stripped of much of its stars and gas, a point highlighted by M110's general lack of star formation. Everybody having fun yet? And now, our final stop, M33, the Triangulum Galaxy, the third and last spiral galaxy of our local group. Located in the small constellation of Triangulum, Latin for triangle, good guess, M33 is about half the size of the Milky Way. The Triangulum Galaxy is 2.7 million light-years from Earth, but it is much closer to the Andromeda Galaxy and moving towards it. If 2 spiral galaxies collide, it may alter the course of the Andromeda Galaxy and prevent the predicted collision with the Milky Way. Well, let's hope so. Now, this important message. We will serve dinner on our return trip to Earth. There's a choice of chicken or fish. We hope you have enjoyed the tour. Hey, if you fill out our survey and give us 5 stars, you can also have dessert. There's a giant ghostly hand that stretches across space. Its eerie fingers are reaching for a glowing red cloud that looks like molten space lava. Although it looks like a scene straight out of a sci-fi movie, it's 100% real. The hand was formed after an enormous star collapsed in a huge supernova explosion. The boom created a new star that is bursting with energy. The energy given off by the star is so big that it caused debris from the explosion to swirl around it. This is what created the supernatural-looking hand. The hand is so big that it stretches a colossal 150 light-years. As for the lava-like structure it's reaching for, that's actually a huge gas cloud. So, while it looks spooky, it's completely harmless, and you can go to sleep tonight without worrying about a giant ghostly space hand scooping you out of bed. There's a bizarre star hidden in the depths of space that seems to randomly flash on and off. It's known as Tabby's star, and its light dims at super irregular intervals for really odd lengths of time. There have been so many theories about what's causing this, from meteor showers to outer space interference. The comet shower idea was quickly debunked. Dust from comets, which would block the light, goes away after a couple of months. Tabby's star fades slowly over decades, so the timing just doesn't add up. It can't be down to planets either, as no planet is big enough to block that much light from a star. After years of speculation, scientists have finally found an explanation for the strange phenomenon. The dimming and brightening are actually a result of space dust. A ring of dust surrounds the star, which often temporarily blocks its light. On day 8 of its mission in 2019, China's lunar rover discovered something really strange on the far side of our moon that caught the attention of the entire world. While navigating a path around a bunch of lunar craters, it spotted something really weird lurking inside one of the moon's holes. It was a colored substance, just like gel, that we'd never encountered before. The curious material was a rich dark green color and glistened like diamonds. After a year of analyzing the foreign substance that measured 20 inches by 6 inches, the scientists finally came to a conclusion. The glistening effect seems to come from glass. In space, it usually appears as a result of lunar impact melts. This means that it's most likely from a comet or rock that has hit the moon and melted upon impact. But while it's likely that the strange substance is just melted rock, scientists aren't 100% sure. This is because the pictures were captured under bad lighting conditions, and there were a bunch of other factors that badly impacted the quality of the images. So, the jury is still out on this one. There's a huge space cucumber floating through the galaxy, and no one really knows where it came from or why it's there. Okay, it's not exactly a cucumber, or a pickle. It's more likely a super elongated rock. Scientists think it may be longer than half a mile, but only 540 feet wide. It's traveling so quickly that there's no way it's bound by our sun's gravity, meaning that the strange object was formed somewhere outside of our solar system. We don't even know how long it's been wandering through space. It's estimated that it entered our solar system during the Victorian era, but who knows where it had traveled before that. For years, we've been told there are 8 planets in our solar system, 9 if you count Pluto, which got kicked out of the club some years ago. But that might all be about to change. There may be an enormous secret world lurking in the midst of our system, which scientists are calling Planet 9. This undiscovered planet could be way out past Neptune. There are seemingly unexplained clusters of orbits there, and this hidden 9th planet would explain this. The planet, if it exists, would be 10 times the size of Earth, take at least 10,000 years to orbit the Sun, and would sit over 200 times further out than our home planet. This is why it's been so tricky to identify, as it's almost impossible to take a picture of. In 2019, 30% of the area that the planet is likely to be in had been searched. It will take at least another 2 years to cover the remaining area. In the meantime, we'll be waiting on the edge of our seats. No. Strange radio waves are beaming down on Earth, and scientists are baffled. These fast radio bursts are sudden, unexplained, and last just milliseconds. We first picked up the weird signals in 2007, and scientists have been scratching their heads ever since. They appear to be coming from outside the Milky Way, millions of light years away. For us to pick them up from that far away, they must be emitting more energy in a fraction of a second than the Sun does in 80 years. Most of these signals only came once, which would have made identifying them much easier, until this all changed in 2017. In August, a signal was picked up that repeated 93 times, ruling out speculation that the signals were being caused by random one-off events. To this day, we still don't know what's causing the signals. Back in 2014, NASA captured a surprising picture of the Sun that showed that it might like to play dress-up. A brilliant storm of magnetic fields caused the Sun to look like a flaming jack-o'-lantern. Even weirder is that the image was captured on October 8th. It was possible because of something called active regions. These are basically areas of the Sun that have greater levels of light and energy. This is what gives the flaming look in the images. The light forms 2 eyes, a nose, and a wide, jagged, smiling mouth. Fortunately, this look was just a coincidence, and there isn't a giant pumpkin carving enthusiast lurking in the depths of space. Hey, I want to know, is this a trick or treat? Space fans spotted what appeared to look like a spoon on the surface of Mars. It was half covered in dust. They noticed it after images from a Mars rover had been released. As spooky as the suspicious silverware may sound, it was just a trick of the light. The spoon is just a regular old rock, albeit in a slightly odd shape. The play of shadows in the photo made the object look even more spoon-like. Maybe there's a dish nearby that the spoon ran away with. A cosmic eyeball floating somewhere among the stars is no regular-sized eye. It measures an incredible 660 miles across. One of Saturn's moons, Tethys, has become a bit of a celeb to space fans. The spherical moon sports a large crater that makes it look exactly like a giant interplanetary eyeball. There's even a set of peaks inside the crater that look like an iris. Saturn has a gang of 60 moons in total, and Tethys isn't the only one that looks like a random Earth object. Prometheus looks like a potato, Atlas resembles a pita bread freshly served from a Greek restaurant, and Mimas even looks like some villain's spacecraft. And then there's this. There's a giant cat's eye right in the middle of space. Its official name is NGC 6543, but that's kind of long and boring, so most people call it the Cat's Eye Nebula. And it's actually one of the first nebulas to have ever been discovered. Like other nebulas, it was formed by a star that shed its outer layer of gas. The gas floated off and produced this amazing and intriguing structure. The star fires off this layer of gas every 1,500 years. Each time it does this, it creates a spectacular new dust shell. Hey, don't get me started on gas. So, you fall right into the heart of the black hole and prepare for a sad end. Well, you don't have to. falling into a black hole won't necessarily destroy you or your spaceship. You have to choose a bigger black hole to survive. If you fall into a small black hole, its event horizon is too narrow, and the gravity increases every inch down. So if you extend your arm forward, the gravity on your fingers is much stronger than on your elbow. This will make your hand lengthen, and you'll feel some discomfort, rather significant to be honest. Things change if you fall into a supermassive black hole, like the ones in the center of galaxies. They can be millions of times heavier than our Sun. Their event horizon is wide, and gravity doesn't change as quickly. So the force you'll feel at your heels and at the top of your head will be about the same, and you can go all the way to the heart of the black hole. This myth is busted. The next myth claims we can save the Earth from a giant asteroid with a big bam. The familiar plot is that a spaceship lands on the surface of an asteroid. A team of astronauts quickly drills a hole in it, leaves a present there, and flies away. Then, bam! As a result, the asteroid may break into several pieces and continue on its way to Earth. Well, big chunks of the asteroid fall to our surface, causing a lot of damage. So, our mission is failed. Well, to save Earth, we need a really big bam. Not only outside the asteroid, but right above its surface. When the boom happens, the force of the blast pushes the asteroid slightly downward. Even a slight change in trajectory would be enough to make the asteroid fly past the Earth in the future. Done! Oh, and if you made a big boom on an asteroid, you'd never be able to hear its loud sound. Yeah, we often hear the sound of spaceships and battle in space in the movies, but that's just a myth. Sound is a wave that spreads because of the vibrations of molecules. A person claps a few feet away from you. The sound wave begins to push the first air molecule next to the clap, then the third, fourth, and so on until the wave reaches your ear. So, to spread sound, we need molecules like air or water. In our atmosphere, sound waves spread out just fine, but space is a vacuum, so it's nothing here. You can clap your hands loudly there, but there just won't be any molecules that can vibrate and carry that sound. One more myth about asteroids. We need to fly a little farther than Mars' orbit. Whoa, we're in an asteroid belt, and we constantly have to dodge giant rocks and blocks of ice. We got in some dense asteroid cloud. Not true. The fact is that space is huge, and the distances are incredible. All the rocks and debris in the asteroid belt are only 4% of the weight of the Moon, so there really aren't that many of them there. To understand the size of the emptiness in space, look at the collision of two galaxies. There are billions of stars in each of them. If we mix them up, it's unlikely there will be any collisions even here. Another myth is that there's zero gravity in our orbit. Imagine you're in a huge box 10 miles up in the air. Now we let go of the box and it starts to fall. You're falling simultaneously with the box at the same speed. And now it's as if you feel zero gravity. Well, the same thing happens in orbit. The International Space Station is 250 miles above the Earth, and it's falling continuously, though not on the surface of the planet, but around it in its orbit. Its speed at this point is about 4.7 miles per second. It could cross the United States from the west coast to the east coast in just 8 minutes. So the astronauts there are experiencing the same thing. They're just falling with the ISS at that speed. Now, let's look at the Moon. It always looks at us with one side. This means the Moon has a dark side and the sun's rays never get there. Well, that's a myth. The whole point is that the Moon is gravitationally locked to the Earth. There are days and nights there too. It's just that this rotation is perfectly aligned with the rotation of the Earth. So, whenever you look at the Moon, you only see one side. Although there are days when the sun shines there too, so it's not the dark side, it's the far side. And we even have pictures of this place. And there's one of the biggest craters in our entire solar system, the South Pole Aitken Basin. It's as wide as 2 states of Texas. One myth that turned out to be untrue is that people have never actually been on the Moon. This is the original spacesuit of the first astronauts who were there. Look at the sole of the shoe. Some people claim there's no way they could have left footprints like this there. Actually, they could. On the moon, the astronauts wore extra boots over their suits, and their soles matched the footprints on the moon perfectly. The astronauts didn't grab them when they left the moon. They left a lot of stuff there, too. They even ripped out the armrests of the seats of the lunar module to reduce its weight. Now, the total weight of human trash on the moon is about 187 tons, including several lunar rovers, spacecraft debris, rocket stages, and lunar probes. That's like 3 Boeing 737s. The next myth is about summer. The hot season comes because the Earth approaches the closest distance to the Sun in a year. The Sun warms our planet more, and we all have to go to the beach. Well, not true. Let's draw an axis through our planet. It's slightly tilted on one side, and winter comes when our planet's axis is tilted away from the Sun. But over time, the axis tilts toward the hot star. Then its rays shine at such an angle that it gets warmer. It's true, though, that the Earth happens to be at different distances from the Sun. This is because our orbit is not a perfect circle, but slightly flattened, an ellipse. Normally, we think of the distance to our star as about 93 million miles, but that distance may be longer or shorter than 3 million miles, depending on which point in our orbit we pass. Another myth about the Sun is that it's yellow. Well, let's send you into space for this one. You look out the window and it's white. The Sun only appears yellow to us through the filter of our atmosphere. The composition of the air and its thickness just distorts the light of the star. But stars do come in different colors. Cooler stars have bright orange and red colors. These are usually very old stars, older than our Sun. But young and very hot stars are bright blue. The Sun is about in the middle of the spectrum. You've also heard about how, if you take your spacesuit off in outer space, you'll blow up like a balloon. Well, our bodies are designed to function at atmospheric pressure, like outside. But space is a vacuum. Imagine a huge metal barrel, and we sucked all the air out from there. Add to that a temperature of minus 455 degrees Fahrenheit, and you have space. If you could get into those conditions, all the air pockets in our body, like our lungs, would start to expand. So you really could blow up like a balloon if it weren't for our elastic tissues. They stretch and bend, so you keep your body size. You'll have enough oxygen in your body to last about 20 seconds. Then your brain will begin to starve, and soon you'll pass out. So you won't blow up, and you won't even freeze because you'll be in a vacuum. It doesn't conduct heat. For example, water conducts heat very well, and you feel cold from it instantly. But you feel better in the air of the same temperature. If you're in the vacuum of space, the super low temperature won't be a problem for you. Much worse is solar radiation. On Earth, we have a shield against radiation in the form of the atmosphere. It blocks the harmful rays. In outer space, you would be defenseless. Another myth is related to cell phones. People think that when you dial your friend's number, your phone sends a signal into space. There are a bunch of satellites out there that will pick up your signal and reflect it like a mirror right into your friend's home. No, not true. However, there are satellite phones in the world that work that way. But when you make a cell phone call, your signal is transmitted through a system of cell towers from one to another until it gets to your friend's phone.
Thousands of strange spaceships sneak into Earth's airspace. They descend to our planet and fly through cities, plunging people into complete chaos. Suddenly, the door of the largest ship opens, and a strange creature comes out. It tries to copy our language and says they had come from a distant star, Proxima Centauri. Something like this might happen because scientists have recently picked up a strange radio signal off that star. Proxima Centauri is the closest star to our solar system. It's only 4.2 light years away. That means a beam of light that starts from this star reaches Earth in 4.2 years. That's also 270,000 distances from Earth to the Sun. The star Proxima Centauri itself is too pale for us to see with the unaided eye in the night sky. But its system hides a little secret. Let's fly there and take a closer look. So here's this red dwarf. It's 7 times smaller than our Sun and 8 times lighter. Proxima Centauri is 1.5 times bigger than Jupiter and almost 150 times heavier. But what we're looking for is a little further away. This is Proxima Centauri b, a planet similar to Earth. It's only 10% larger than Earth and is in the habitable zone of the star. It's the perfect distance, not too far away and not too close. So the temperature isn't too high or low there either. Water, if it exists on that planet, can be in a liquid state. And so, life can survive and evolve there. Maybe it's developed enough to send us the signal that we had received. A radio signal is basically waves. They have a certain frequency and length, and we can always tell an artificial signal from a naturally generated one. The signal that we picked up from Proxima Centauri b had a frequency of 982 megahertz. The regular radio we listen to in the kitchen or in the car picks up signals around 100 megahertz. That's why scientists have concluded that the signal was created artificially. Such signals could have a way of communication between the developed worlds. If this is really a message from an outer space civilian, we should be able to decode it. For this, any civilization must use the simplest method of encryption. For example, Earth has already sent a radio signal into space. It was the Arecibo message. This message consists of 1,679 digits. It's a rectangle of 23 by 73 squares that has information about our civilization encoded using a binary code. At the top of the rectangle, there's a system of numbers that we use. They're marked in white. This purple thing is the key to read the next part of the message. The atomic numbers of the elements like hydrogen, carbon, nitrogen, oxygen, and phosphorus are encoded in this key. These are the key elements that can start life. If those who receive this signal can make sense of the numbers in the key, they can read the next part of the message. These green things are the building blocks of our DNA chain. And right at the bottom here is the DNA chain itself. The white rectangle indicates the number of pairs of these building blocks, and the blue spirals show the shape of a DNA chain. And then we see the human silhouette itself. The white and blue object to its left is a coded number of our average height. The human itself is drawn here at the ends of the DNA strand, so that the outer space civilization can understand what we look like. And the white rectangle to the right of the human sketch is the number of Earth's population at the time of the message. That's 4.2 billion as of 1974, almost half the number we have now. The next part is a drawing of our solar system. The big yellow square is the sun. Then come all the planets in our solar system, including Pluto. Earth is shifted up a bit here, so that outer space civilization can understand where this message is coming from. In the last drawing is the observatory from which this message had been sent into space. This signal is now on its way to the M13 star cluster 25,000 light years away from Earth, so it won't get there for another 25,000 years. And we'll need another 25 to get a response if there is really someone on the other side who can receive the signal. If the signal from Proxima Centauri is also a message, we'll need time to decode it. So let's fire up our super-powered computing machine and wait for the result. But this isn't the first mystery signal we've ever picked up on Earth. Scientists recorded an unusual wow signal in 1977. They supposed it came from somewhere in the constellation of Sagittarius. The telescope was picking up the unknown signal for an impressive 72 seconds. Later, a scientist who looked at the printout of the signal concluded that the signal was artificial. He wrote, "Wow," on the printout as his reaction. The following observations and studies couldn't catch this signal again. Some theories said that this signal came from a celestial spaceship flying by. It had flown away, and we could no longer detect the signal. But most likely, this signal was created on Earth. It was directed upward but reflected off an object at a high altitude. It could have been an airplane, a satellite, or space debris orbiting our planet. Then the signal was picked up by the telescope, and because it was human-made, all of its characteristics, like wavelength and frequency, could have confused scientists. In 2017, scientists recorded a flare on Proxima Centauri. The star's brightness increased by 1,000 times in just 10 seconds. Before that, there was another flare there that was weaker but lasted about 2 minutes. With these flares, Proxima Centauri has emitted enormous amounts of radiation. Even if there was life on the star's companion planet, these flares would have likely destroyed it. The stellar winds would have simply blown the atmosphere off the planet and made its surface lifeless. Overall, the planet Proxima Centauri b receives 60 times more high-energy radiation and 400 times more X-ray radiation than Earth. Scientists have concluded that the probability of life here is 1 to 100 million. And while we don't know yet for sure if the signal was artificial or natural, the scenario of a bunch of spaceships coming to Earth is most likely possible. Our only method for searching for outer space civilizations is using radio waves. They're like loud noise that blasts away from our planet in different directions at the speed of light. The main problem here is the gigantic distances. Our galaxy, the Milky Way, is 100,000 light-years wide. Suppose there's life at the other end of it. If we send a radio signal to them, it won't reach that supposed planet for another 100,000 years. And we won't get a response for another 100,000 years. It's the same if someone once wanted to contact us. We didn't learn how to create and receive radio signals until the 19th century. If a civilization was developing at the same time as us somewhere in the Milky Way and they invented the radio, we won't get their signal for several millennia. Plus, the radio noise from our planet is starting to fade away. We use Bluetooth, fiber optics, cable TV. So in about 100 years, we'll no longer be visible to other worlds. Or worse, what if there was an outer space civilization somewhere that was sending signals into space? The signals were reaching our planet, but we didn't yet have the technology to pick them up. The world that was sending the signal has evolved, and the signal went out. We could have caught those remnants of the radio waves that were moving through the universe, but we set up the antennas too late. There are about 2 trillion galaxies in the universe. Each of them contains billions and trillions of stars similar to our sun. Maybe there's a planet near one of them that looks like ours. Life could be blooming there. And this outer space civilization, just like us, is looking through telescopes in hopes to catch the radio signal from an unknown planet.
Very recently, astronomers have found 3 potential super-Earth planets orbiting a somewhat close orange dwarf star. The term super-Earth is used to describe a planet beyond the solar system with a mass higher than that of Earth but below those of the ice giants of the solar system, Uranus and Neptune. An international team of researchers, led by Dr. Shweta Dalal from the University of Exeter, found that the exoplanets were orbiting star HD 48498, which is located around 55 light-years away from Earth. The planets travel around their star in 7, 38, and 151 Earth days, respectively. The study describing these findings appeared in the journal MinRes on the 24th of June, 2024. The coolest thing here is that the outermost exoplanet candidate orbits in the habitable zone of its host star, and the conditions there might be comfortable enough for liquid water to exist on the surface without boiling or freezing. Such habitable regions around stars are also known as the Goldilocks zone and are believed to be ideal for potentially supporting life. Another reason this discovery is so important is that the orange host star is like our Sun. But since it's an orange dwarf, it produces less radiation than our yellow dwarf star. It's also the closest planetary system to host a super-Earth in the habitable zone of a Sun-like star, which makes this discovery super exciting. It can help us move forward in our quest to locate habitable planets around solar-type stars. Who knows? Maybe this planet will be our new home one day. These potential super-Earths were detected thanks to the HARPS and Rocky Planet Search Program. Throughout a decade, the team taking part in this research has collected nearly 190 high-precision measurements using special equipment. By analyzing the spectrum of light coming from a star, astronomers can figure out whether it's moving toward us, this is known as blue shift, or away from us, that's what we call red shift. And still, to make sure their findings were correct, the team used lots of different methods and comparative analysis. Everything confirmed their conclusions. There indeed are 3 planetary candidates with minimum masses ranging from 5 to 11 times the mass of our home planet. The team also believes that the proximity of the star, together with the outermost planet's favorable orbit, can make this system a great target for future studies. Hopefully, further research will open doors for our understanding of planetary systems and the potential of life outside our solar system. Scientists have already discovered more than 5,000 exoplanets, which are planets outside the solar system, since the first such world was confirmed orbiting a Sun-like star in 1995. To find those distant planets, astronomers use different equipment, like NASA's Kepler Space Telescope, launched in 2009. Its mission was to find as many Earth-like planets dwelling in the Milky Way galaxy as possible. But it's not the only instrument used for searching exoplanets. Anyway, now let's look at the most exciting and promising of these worlds. Gliese 667 cc is a mere 22 light-years from Earth. But even though it seems close, it's still around 129 trillion miles away from us. The planet itself is around 3.8 times as massive as Earth and completes one orbit around its host star within 28 days. In other words, a year on that Earth-like planet is 13 times shorter than a year on our planet. Luckily, the star is a cool red dwarf, so the exoplanet most likely lies in its habitable zone. But there's still a chance that this world might be regularly baked by the flares coming from its parent star, which is not cool on many different levels. Kepler 22b is way further away than the previous world, more than 600 light-years away from our planet. It was the very first Kepler planet found in the habitable zone of its star. This world is larger than Earth. It's about 2.4 times our planet size. Sadly, we still don't know whether this planet is rocky, liquid, or gaseous. The orbit of Kepler 22b is similar to Earth's. It takes the planet 290 days to orbit its G-class star, which is kind of like our Sun. But this star is smaller and colder than ours. Another Kepler planet, this time it's Kepler 69c. It lies a whopping 2,700 light-years away from us. This world is also almost 70% larger than Earth. Researchers know nothing about its composition, but they found out that the planet needs 240 days to complete one orbit. This makes its position in its system like that of Venus in our solar system. At the same time, this world might be more habitable than Venus since its host star is a bit less luminous, 80% of our Sun. TOI 733b is a recently discovered world. It was found in 2023. It's out there, 245 light-years away from Earth, and needs just 4.9 Earth days to complete an orbit around its star. But the coolest thing about this planet is that it might have a massive ocean. According to scientists, the planet is likely to be completely covered with water. Does that mean there could be life on this super-Earth? Time will tell. GJ 1214b is located 48 light-years from Earth. This planet is a super-Earth, almost 3 times bigger in diameter and 8 times heavier than our home. It orbits around its red dwarf star faster than you can binge-watch your favorite series, finishing a complete loop every 38 hours. But it's not just the planet's size or orbit that's out of this world. It's pretty hot out there, with mind-melting 450 degrees Fahrenheit. But the coolest thing is that this planet is practically drowning in water. The sizzling temperatures and crazy high pressures on JG 1214b create some cool materials like hot ice and superfluid water. Superfluidity is something that happens in liquid helium when it's almost as cold as it can get. On Earth, water totally missed the memo about being superfluid because it needs ridiculously low temperatures and off-the-chart pressures to pull off that trick. Still, there's not much use in superfluid water. Even if you try it, you'll just get dehydrated. The super-Earth that's closest to us was discovered in 2016, and it's called Proxima Centauri b. It's located a mere 4 light-years away from Earth and has a mass remarkably similar to that of our planet. A year on Proxima Centauri b is short. It only takes the planet 11.2 days to complete a circle around its central star. Scientists discovered this world after they noticed that its parent star was slightly wobbling. They hadn't been sure what exactly had been happening there until they realized Proxima Centauri b's gravity probably produced pulls and tugs that caused these wobbles. Although the exoplanet is traveling in the habitable zone of its star, Proxima Centauri, it is exposed to extreme ultraviolet radiation, all because it lies very close to its parent star. Also, none of the telescopes that are currently working and exploring exoplanets are positioned well enough to capture the light from the atmosphere of this super-Earth. Most things there are still a mystery to us, even though we're talking about a planet that's really close. Super-Earth TOI 715b orbits a red dwarf, a star smaller and cooler than our Sun. At the moment, such stars remain prime candidates for finding habitable planets orbiting them. Those miniature rocky worlds have far closer orbits than those circling around stars like our Sun. But since red dwarfs are small and cool, the planets don't risk anything when crowding closer. They're still safely within a star's habitable zone. Experts say that TOI 715b might have once had an atmosphere thicker than that of Neptune, and now the planet could be in a transition state where it's losing its atmosphere. To confirm this suspicion, scientists need to do more research, and they might finally learn whether this planet is a watery terrestrial planet.
The weird thing about Fomalhaut b isn't its name, but the fact that it doesn't exist. It was first photographed back in 2008 and was a sensation. Scientists believe it to be a massive exoplanet, but it turned out to have low mass, and it's falling to pieces of dust at the moment. It acts like a massive dust cloud. Gliese 1214b is quite extraordinary with its steamy environment. Wait, but steam is the result of water evaporation, isn't it? In fact, this hot planet is full of water-like substances. It's definitely hotter than our planet, with its 250 to 540 degrees Fahrenheit. It can also be an ocean planet. Still, very little is known about it since it was first discovered only back in 2009. If you ever wondered what it's like to walk on ice and hot coals at the same time, meet Gliese 436b. Being extremely close to its sun, the Neptune-sized exoplanet boasts temperatures hotter than a blazing oven. And yet, it's covered in ice, which burns incessantly. This ice is much denser due to the enormous gravity of the planet, staying solid even under extreme conditions and not melting away. But Gliese seems a nice place with quite mild climate compared to an oven-like Corot 7b. Its day-to-day temperature is over 4,000 degrees Fahrenheit. Combined with the rocky surface, it presents a kind of underworld landscape. The rocks on the ground bubble and boil, evaporating in the atmosphere, where they cool down and eventually fall back on the surface in a brimstone rain. The saddest thing about Corot 7b is that it might have once been a gas giant whose atmosphere melted away from the heat, leaving only the scorched core. Corot XO 3b is neither as hot as the previous one, nor as cold as many other planets. It's a gas giant similar in size to Jupiter, yet 20 times denser. It makes this exoplanet's gravity weigh down on everything on its surface 50 times more than it would on Earth. Stepping on it would be your ultimate doom, because you'd be immediately crushed by the density of its atmosphere. TRES 2b is a planet where night never ends. And it's not your regular night with stars shining in the beautiful skies. Here, it's pitch dark and scorching hot. TRES 2b is a gas giant, roughly 1.5 times more massive than Jupiter, and its surface absorbs light better than charcoal. It might also have a faint dark red glow because of its burning air, which is as hot as fresh lava. It may mistakenly seem that Saturn does have an Earthen-friendly environment. Some layers of this giant gas sphere actually have quite nice temperature conditions. If you dive into Saturn, you'll get to a layer with liquid molecules with 32 degrees Fahrenheit, which seems like Earth. Anyway, it's only one minor layer, and the rest of the planet is freezing cold. So you'll never be able to land on Saturn and be the same human being like you are on Earth. But you can become a sort of snowball there, or an ice crystal. As for Jupiter, you might have already guessed that there's no solid land. This planet is made of hydrogen and helium, so it's another gas sphere you can't walk on. It's a bit different from Saturn, though. You wouldn't dive in Jupiter, you'd rather float on it. This planet is like a giant cloud, and if you ever landed on it, it would be like walking through a super thick fog. The temperatures fluctuate a lot here. It's freezing on the surface. Unlike Saturn, the deeper you dive, the more scorching this gas sphere gets. Oxygen is usually viewed as an element that might bring life to a planet, but this is definitely not the case for Osiris. Scientists were shocked to find oxygen on this planet, or rather around it, because it's 8 times closer to its star than Mercury is to the Sun. This extreme distance makes Osiris a living melting pot where anything that could burn will. It's also responsible for a very short orbit of the planet around its star. A year on Osiris is just 3.5 days on Earth. To boot, the atmosphere of the planet is constantly blown and melted away by the heat from its sun. WASP 76b is another weirdly dangerous planet where it rains. No, not wasps. It's so hot out there, over 4,300 degrees Fahrenheit, that it vaporizes iron. So, it rains iron. It's another gas giant, just like Jupiter. Its extreme proximity to the Sun divides the planet in two. One half has a never-ending day, while the other has eternal night. Meet WASP 12b, one of the weirdest and saddest planets out there. The enormous gravity of its star, combined with the planet consisting mostly of gas, result in the star slowly devouring its protege. WASP 12b has already taken the form of an egg, stretched towards its merciless sun and unable to do anything with its condition. In another 10 million years, the planet will inevitably succumb to the voracious star's appetite. No list of the weirdest planets could do without mentioning Venus, the Earth's evil twin. The second planet from the Sun has an atmosphere so thick and full of clouds that its surface is much hotter than that of Mercury, despite being somewhat farther from the Sun. Volcanic eruptions constantly thrash Venus. Its gravity is almost 100 times stronger than ours, and those clouds I mentioned are not made of water, but of sulfuric acid, which condenses and rains down on the ground, adding to the inferno. But even if you were brave, or crazy, enough to try to pass through those clouds, you probably couldn't. The winds up there are as strong as some of the most powerful hurricanes back on Earth. One more freezing cold planet is the one I dare not pronounce. Although the host star is not too far away, it's a small and rather cool red dwarf whose light and heat barely even reach the planet. The temperatures out there fall as low as negative 370 degrees Fahrenheit, which is only marginally warmer than absolute zero. The exoplanet is thus dark, gloomy, and covered in eternal ice. Still, if it has a rocky core, it might generate some heat, so there is a chance that deep below the frozen surface, we could build a nice thermal spa hotel for space travelers. The next planet that sounds like a tongue twister is the only exoplanet in the orbit of its star, and at first glance, it looks quite pretty. Blue and white swirls making up wondrous patterns on the surface. But these pleasant colors actually come from hard silicate particles in the planet's atmosphere, which means it rains glass here. But the worst thing is that winds reach the speed of 5,400 miles per hour, or almost Mach 7. For comparison, the fastest wind speed on Earth was 254 miles per hour, over 20 times less. Thus, the glass falling from the sky travels horizontally at hypersonic speeds, shredding everything in its path. Here's another name we'll just leave on the screen, thank you. This magnetic rogue planet, let's call it SIMP, has probably the best auroras in the universe, putting our northern lights to shame. Dimidium, located roughly 50 light-years away from our solar system, is a planet hostile to any living thing on many accounts. It's tidally locked to its sun, which means one of its sides is always facing the star, while the other is always turned away. The hot side is heated to over 1,800 degrees Fahrenheit, perpetually blown over with winds reaching 600 miles per hour. Despite Dimidium being a gas giant, it has a large amount of iron in it, which melts and evaporates in the atmosphere, creating clouds. And when these cool down, they fall on the surface in the infernal rain of molten iron. In the star system of 55 Cancri, there are 5 planets, 4 of which are gas giants similar to Jupiter and Saturn. But the 5th one, or rather, the first, because it's closest to the star, is different in a most horrible way. 55 Cancri e is so close to its sun that half the planet's surface is a literal ocean of molten lava. The other half is in eternal darkness because it never sees the sun. The planet is always turned to its star with one side. And between the scorching and the dark, there's the twilight zone, a thin strip of gloomy nothingness. The system, whose name I wouldn't even try to pronounce, has 3 exoplanets, which are all being slowly destroyed by their own star. It happens because that star is not a regular one. It's a pulsar, a rapidly spinning core of an exploded star. It creates powerful electromagnetic pulses in several directions, while rotating at several thousand times per second. As a result, the planets orbiting this deceased star are slowly being eaten away and will eventually disappear entirely.
The planet races through space. Its orbit is unstable, like a pool ball gliding across the table looking for a target to collide into. Only this ball is the size of Mars, and it's going 9,000 miles per hour. Boom! It crashes into another planet. This Mars-sized object was called Theia, and what it smashed into was Earth. The impact released 100 million times more energy than the asteroid that wiped out the dinosaurs. The planetary collision threw tons of solid material from both objects out into space. But only one of the bodies survived. Theia was obliterated and then swallowed entirely by early Earth. But that debris didn't go flying endlessly into the cosmic void. No, something crucial happened. All those solid chunks gathered into a cloud. Gravity squished it together, pressing more and more. And in the end, our moon was born. So goes the theory. At the time of the impact, the solar system was just forming, and this rendezvous of epic proportions probably wouldn't have happened if it weren't for a newly formed Jupiter throwing Theia off its orbit and straight into Earth. Our young planet withstood the blow. Time passed. Earth evolved. Its surface will become unrecognizable over the next 4.5 billion years. It's hard for the human mind to understand this vast amount of time, so we'll squeeze it all into one day. If midnight is when Earth first formed from gas and dust that remained after the Sun's creation, the next 4 hours show a lifeless planet. Red hot, covered in lava, constantly bombarded by asteroids and, as you know by now, even a whole other planet. Yet life finds a way. The first cells appear. It's 4 a.m. on the clock. At 2:08 p.m., we see the first single-celled organisms form. It's not until 8:28 p.m. that sea plants appear. 20 minutes later, what's this? Jellyfish. After them, the planet flourishes with different fish, reptiles, insects. The forests grow at 10:30 p.m. Between 10:56 and 11:40, dinosaurs roamed the Earth. The giant lizards ruled our planet for less than 1 hour. A minute before the dinosaurs' extinction at 11:39 p.m., the first mammals begin to run around the planet. At 11:58 and 43 seconds, humans appear. In the cosmic scale of things, we've only ruled this planet for 1 minute and 17 seconds. So here's the main question baffling scientists. Why didn't life on Earth ever stop? It had every chance to cease. Why didn't our planet become like Venus or Mars? They both once had an atmosphere and oceans. Today, they're lifeless deserts. Forget about complex scientific concepts and theories of the universe's structure. Our little rock and all its inhabitants are just incredibly lucky. Professor Toby Tyrrell at the University of Southampton used computer programs and climate simulations to solve the puzzle of why asteroid collisions in ice ages didn't turn our little rock into a lifeless wasteland. The research team took not 10, 100, or 1,000 virtual planets similar to Earth. They used 100,000 for the experiment. And every single one of those 100,000 were simulated 100 times. They exposed these virtual planets to different phenomena. They were bombarded by asteroids, frozen, exposed to epic eruptions of supervolcanoes that blacken the skies and block the surface from the sun's rays. Just 9%, or 8,700 of them, were successful one time in 100 simulations. Of that group, 4,500 planets remain inhabited 10 times. Only on one planet out of 100,000, life didn't stop all 100 times. If life is a lottery, Earth got extremely lucky. In 2009, the unique Kepler telescope was launched into space. Its task? Search one patch of the night sky, or 150,000 stars, for rocky Earth-like planets. Over 9 years in service, it ended up surveying more than 500,000 stars. In all that time, with all those observations over nearly a decade, Kepler discovered 2,600 possible Earth-like planets. The weird thing is, most of them are a type you can't find in our own solar system. They're something between the size of Earth and Neptune. But back to the real Earth. If you go far from the city and look up at the sky, you'll see an ocean of stars. If you're lucky and it's a clear night, with an unaided eye, you could count a maximum of 2,500 points of light. Yet, there are at least 100 billion stars in the Milky Way. Some estimates put the numbers of stars in the Milky Way up to 400 billion. So, where's this giant range coming from? Well, counting stars isn't exactly an easy job. Scientists obviously don't number each one individually, 1, 2, 3, and so on. You know how long it takes to count just 1 billion? Over 100 years. Now, multiply that by 400. Instead, they look at small patches of space and use some complex scientific formulas to make educated guesses of how many stars there are in total. You can do a similar experiment yourself. Imagine a bucket filled with 10 pounds of rock, sand, soil, and other items. Your job? Understand how many rocks are in that mix. We'll count only those rocks that are visible to us from above. Get a rough estimate of their volume and weight, what percentage of the total we can see, and with some calculation, you can get a number. Is it exact? Nah. Why? Because you can't know if the rocks in the bucket are spread evenly throughout, or if they're all about the same size throughout. What if the ones at the bottom, if there are any, are bigger or smaller than your sample view? They could have completely different weights and volumes. That bucket is our Milky Way galaxy, and the rocks you are counting are stars. The point? Scientists can't know for sure how many stars there really are. Maybe 100 billion, or perhaps 4 times that. Of those, 4 billion are like our Sun. With our own galaxy, the most accepted estimate for planets that could potentially support life is 300 million. Though, as the tradition of scientific inexactness goes, that number could be up to 5 billion or more. Either way, lots of real estate to choose from. And that's just the Milky Way. But get this, it's just one of 200 billion galaxies in the observable universe. The most recent research puts that number 10 times higher, something like trillions of galaxies in space. And we've only studied less than 10% of them. As for how many stars there are in the universe, scientists put it at 1 septillion. That's 1 followed by 24 zeros. Again, it's all estimates because we can't know for sure. So far, one thing is clear. Our Earth is the only place in the universe that we know of where there's life. And this planet has done everything it can to change that. Over the past 540 million years, more than 20 major extinction events have occurred. The last one was 66 million years ago. Yep, it was the one that took out the dinosaurs, and 75% of all life on this planet for that matter. An object 7 miles across in diameter smashed into our planet. It was going 120 times faster than the fastest car today. Over 900,000 miles all around the impact site, everything caught fire. A huge tsunami swept across the world's oceans. Billions of tons of dust and sulfur rose into the sky and blocked the sun's warm rays. A global cooling came to Earth. A little over 200 million years ago, there was a lesser-known extinction event that wiped out half of all life on the planet. Most likely volcanoes or an asteroid strike are to blame. Other theories say the movement of tectonic plates triggered another ice age. At that time, huge crocodiles ruled the Earth. They disappeared, and new animals entered the arena of history – dinosaurs. But the worst this planet has ever seen was the Permian-Triassic event about 250 million years ago. 80% of marine life, 70% of land animals and plants, all gone. Volcanoes spewed out a colossal amount of lava where modern-day Siberia is, but it affected the entire planet. Around 445 million years ago, the dominant life form on our planet was marine invertebrates. There was only one continent, Gondwana, and plants were just starting to flourish on land. But something happened that took out 75 to 85% of all living organisms. It could have been an ice age, rising temperatures, or a more daring theory. Some think it could have been a huge star exploding 6,000 light-years from Earth. It launched a jet-like gamma-ray burst that ripped across space, and poor little Earth happened to be in its path. It burned off the ozone layer instantly. Yeah, we kinda need that thing to protect us. Case in point, no matter how much this planet, or even the universe, tries to wipe out life on Earth, which is here in the first place from unbelievable odds, life always finds a way.
We've been focusing on trying to find life on Mars so much, while there is this gem waiting to be explored. This planet is the 6th farthest from the Sun and the 2nd largest in the solar system. You'll find it right behind Jupiter. I'm talking about Saturn, or as they sometimes call it, the jewel of the solar system. It's so different from our planet. First of all, you wouldn't be able to stand there. While Earth consists of rock and other tough stuff, this planet is like a giant ball, mostly made of gases. If you found a swimming pool huge enough to fit Saturn, you could see the planet floating in the water. No wonder, Saturn is the least dense planet in the solar system. It also contains a lot of helium. You know, the gas you put in balloons to make them hover in the air. Saturn is a very windy planet. Winds there are more than 4 times stronger than the ones we have on Earth. A day over there lasts 10 hours and 14 minutes because Saturn spins on its axis pretty fast. But the planet takes its time while going around the Sun. A year there equals 29 Earth years. Saturn's radius is more than 36,000 miles. It means the gas giant is 9 times wider than our planet. If Earth was the size of a nickel, Saturn would be as big as a volleyball. Even though some of our planets in our solar system also have rings, Saturn's are the most spectacular ones. You can even see its rings from Earth. And no, you don't have to be a scientist with insanely expensive equipment. All you need is a small telescope. Saturn's rings are not firm. They are made of pieces of dust, rock, and ice. Some of them are as small as grains of sand, and some as big as a house or even a mountain. These are actually bits of asteroids, comets, and shattered moons that fell apart before reaching Saturn. They could be torn into pieces by the planet's powerful gravitational pull. Saturn has over 50 moons, and recently, scientists have discovered some unusual hydrothermal activity on one of them. Enceladus is Saturn's 6th biggest moon. It has 4 tiger stripes close to one of its poles. Researchers have found that there is an ocean underneath these stripes. Water and ice erupt from that area, so now we can't but wonder, maybe there's life out there. In the oceans on Earth, some forms of life gather around similar hydrothermal vents. They feed on the chemicals there, same as plants on the surface do with sunlight. And not only that, some of the oldest microbial life on our planet feed on the same energy as the one produced beneath the ocean's surface on Enceladus. It could potentially mean there's life developing there right now. Of course, it takes millions and millions of years for even the simplest organisms to appear. But hopefully, scientists will need less time to find more complex forms of life. There are millions of exoplanets out there in space, and scientists have been searching for those that could be potentially habitable. Exoplanets are planets orbiting a star outside of our solar system. Dwarf stars are similar, less luminous than the Sun. They sometimes live for more than 10 billion years. That's enough time for a living organism to develop and evolve into a more complex form. Life might appear on the planets orbiting such dwarf stars, or, like with Saturn, on one of their moons. And here it is, Gliese 876b, that orbits the red dwarf star Gliese 876. This planet is mostly a mystery, but scientists assume this is a gas giant that has no solid surface. They believe its atmosphere doesn't have clouds, but there might be water in its liquid form on the planet's surface. Teegarden's B orbits a red dwarf that's around 12 light-years away from our solar system. The planet's mass is just a bit higher than that of Earth. Scientists think it may have a rocky surface. The planet needs around 5 days to complete its orbit. It means that 1 year on Teegarden's B is actually shorter than 1 week on Earth. Somewhere far, far away, there's another potentially habitable planet named Kepler 1638b. Okay, to be more precise, it's 3,000 light-years away from Earth in the constellation Cygnus. This planet is 4 times as heavy as Earth and twice as wide. It needs almost 260 days to complete 1 orbit around its star. The gravity on this planet is stronger than that on Earth. It wouldn't be an easy feat to jump on its surface. One more Kepler coming along. This time, it's Kepler 62e, a planet that's more than 1.5 times the size of Earth. Scientists believe this one has a warm, humid, and hospitable atmosphere with cloudy skies. There are 1,200 light-years between Earth and this planet. Kepler 62e needs 122 days to orbit its red dwarf star. Its neighbor, Kepler 62f, is another potentially habitable zone. It's a world around 40% bigger than Earth. Scientists think this planet might be covered in water. The oceans on our planet are full of interesting creatures and organisms of all sizes, so the chances are this planet also hides some intriguing living beings, or at least it has the potential to develop life. When we say habitable, it doesn't mean life definitely exists there. It just means there are conditions for some forms of life to develop. LHS 1140b is a planet located in one of the potentially habitable zones. Unlike its gas companions, it's solid and quite rocky. The planet's radius is 60% larger than that of Earth, and its mass is 7 times bigger. It's one of the densest planets found out there. Since the planet has a big mass, an atmosphere there must be rather thick. Plus, gravity on its surface is much stronger than here on Earth. That's why you would likely have problems just standing on that planet. Hello and greetings from TRAPPIST-1, an ultra-cool dwarf in the constellation Aquarius. It's around 39 light-years away from us. 7 Earth-sized rocky planets are orbiting in the star's habitable zone. All of them can potentially have some water on their surfaces. The temperature on these planets is more or less similar to that on Earth. On the Moon, gravity is only 16% of what we have on our home planet. That's why the astronauts could hardly control their movements when they visited our natural satellite. But when it comes to the gravity on TRAPPIST-1 planets, you would probably feel good and comfortable there. And Kepler, once again. This time it's Kepler 452b. It's a rocky planet 60% larger than Earth. Its parent star is similar to our Sun. This planet has actually spent around 6 billion years in the habitable zone, while Earth has been there for a mere 4.5 billion years. This planet needs 385 days to orbit Kepler 452. This star is around 20% brighter than our Sun, but has the same temperature. The whole system is very far from our little oasis. It would take you 28 million years to get there. And now, how about KOI 7711.01? It's another intriguing world 1,700 light-years away from us. This planet is only 30% bigger than Earth. It gets almost the same amount of heat as we receive from our Sun. Sometime in the future, people might start colonizing the galaxy. They would be looking for new planets to live on. Then we'd certainly have to make really long trips, and maybe one day we'd reach Proxima Centauri. It's a nearby star that has a couple of planets we could potentially inhabit, like Proxima Centauri b. It's around 4 light-years away from Earth, and it doesn't sound that far at first, but it actually is. It would take about 6,300 years to travel there, if we use the technologies that are available these days. It would mean many, many generations to make a trip like that, and it would take even longer to finally inhabit that new world. People would be born and raised on spaceships. They would live their lives there without ever seeing either Earth or the planet they're heading to. Instead of trees, mountains, and rivers, there would be only the dark nothingness of faraway galaxies spreading in front of them. They would never be able to wander unknown streets, breathe in the fresh air, feel the wind. The only place for them to travel to would be another part of the ship. Certainly, such a journey wouldn't be simple, but it would pay off if people managed to build some more beautiful worlds, like the one we have here on Earth. Is that even possible? Time will tell.
It's the year 2600, and the New Frontiers program has finally begun. You've got the list of planets to plan dwellings for, and the first one is Venus. The Earth's evil twin sister meets you with a refreshing 800 degrees Fahrenheit and a beautiful sulfuric acid rainstorm. First of all, the heat means living on the surface here is next to impossible, so you immediately put the prospective house several dozen feet underground. The walls, floor, and ceiling must be made of some heat-resistant and durable material, so you make them out of hafnium carbide. Discovered way back in 2016, it withstands temperatures of over 7,000 degrees. Next, you install the air cooling and purification system. It captures the toxic air from the Venusian atmosphere and pulls it through a complex network of filters, delivering breathable air to the dwelling. As an added benefit, the temperature of this air can be easily turned up thanks to what's going on outside. You can create a separate room below the main space and dub it the generator room. The device there will use the almost infinite geothermal energy of the planet to provide the house with electricity. You think for a moment and add a geothermal bathroom as well. There's no water on Venus, but it can be extracted and separated from its acidic clouds. The piping system would include a heating unit for hot water and a cooling unit with liquid nitrogen for cold water. Another separate space is the garden. Since no plants can survive on the surface, you create a spacious hall with bright lights on the ceiling and a sprinkler system throughout the area. You have large patches of soil for vegetables, several acres for fruit plants, and a big patch in the center for a couple of long-living trees like oaks. They'll provide additional oxygen for the whole building. The garden is encased in a shell of hafnium carbide as well, so that the plants don't wilt in the excess heat of the Venusian soil. You check if everything's accounted for and go to your next stop. Saturn. It's a gas planet, but there's a thin yet stable layer that can be called the sweet spot. Its temperature is just right for humans to feel fine. You create a hover platform to build your house on. There's just no solid ground on Saturn at all. The platform's equipped with wind-powered turbines. The winds on the gas giant reach incredible speeds, so it will need to counteract them, at the same time feeding from the hurricanes. The pressure and temperature are just about right in this place, so your main concern is the wind again. You make the dwelling low and looking almost like a frisbee for better aerodynamics. The walls and roof are made from a single slab of sturdy metal, so that powerful gusts can't tear the roof away. You also make them several feet thick and add some windows with space-grade glass panes that won't break. Water can be extracted from another layer using a series of similar platforms with built-in pipes. Electricity and heat are no problem either, thanks to the powerful winds. The only problem here is food, but it can be imported from other inhabited planets at first, along with the fertile soil for the garden. You create a space for it on another hover platform for the future. Satisfied with your results, you head to the next destination on your list, Europa. This moon of Jupiter's is covered in a miles-thick crust of ice full of canyons and crevices. But deep below, there's a whole ocean of salt water bigger than all the oceans on old Earth taken together. You take it into account and go for an underground dwelling again. The temperature is freezing, but the closer you are to the hot planetary core, the warmer it is. You place the dwelling as deep as you can to safely extract water from the underground ocean. The walls and ceiling are padded with insulation, and in the cellar, there's a home water purification system that turns salty water into the potable kind. Since there's no atmosphere to speak of, the breathable air is extracted from the ice. As it melts, the water vapor is collected and filtered, then enriched with other necessary substances and delivered to the dwelling. As for food, you go for an unusual solution. edible marine plants and fish. You create a separate tank to cultivate algae right in the ocean, and different kinds of fish can be imported from old Earth and other inhabited planets to breed on Europa. Next stop, Pluto. The tiny dwarf planet, just 1/6 of old Earth in width, has a great potential for terraforming, so you immediately create a big dome for your dwelling. The sun shines much weaker here than in any other place in the solar system, so you make sunlight-enhancing panels all across the dome. They'll allow the surface underneath to receive more light and warmth, bringing the area to a comfortable temperature. The ice on Pluto consists of frozen water, just like on Earth, so you build a station for melting it and collecting the resulting liquid into large tanks for later use. There's also a possible liquid ocean deep under the surface, so you add a deep drilling platform, but put a question mark on it. You don't know if it's going to be useful yet. With the area warmed up and well lit, you make a pretty ordinary dwelling like ones we're used to on old Earth and terraformed Mars. A couple of stories, carbon or titanium alloyed walls and ceiling for durability, and a fortified cellar. Still, you also add emergency insulation padding that will only trigger if something happens to the lighting dome. If it's breached, the temperature will quickly drop to below freezing. There's also very little atmosphere on Pluto, so breathable air will have to be generated from the ice again. This time, you combine the water collecting system with the air generating facility. While one produces potable water, the other will collect vapor and enhance it with all the necessary elements. You even go as far as to create a weather controlling device. It will heat up or cool down different layers of the produced air and mix them together to create winds and rain clouds just like on old Earth. This will allow crops to grow in a more natural environment, and Pluto might even become a green planet one day. Right above, in the dark blue sky, Pluto's biggest moon, Charon, is hanging. It's half the dwarf planet in size, which makes it a spectacular view. Its climate is almost identical to that of Pluto's. In a fit of inspiration, you create a vacation home for Plutonians. Here, under a similar dome, they'll be able to explore another little world and look at their dwarf planet from the other side. Which is always the same side, by the way, like the Earth's moon, which reminds you of the next destination. Zarmina, previously known as Gliese 581g, is 41 light-years away, the longest trip so far. The planet's tidally locked to its sun, which means there's perpetual day on its one side and eternal night on the other. It's not only about light, but heat as well. The day side is much hotter, and the night side is partially covered in ice. Unless we terraform the planet, the most comfortable area to inhabit is right between the two sides, called the Terminator Zone. It's neither too hot nor too cold here, and there's an eternal twilight. The sun is always just above the horizon. The good news is that the atmosphere on Zarmina, although volatile, is rather close to the old Earth's, but you still cover the selected area with a protective dome just in case. Human dwellings here don't have to be specially protected from the elements, and there's liquid water too. You build a pretty generic house, much like the one on Pluto, but then add a few crucial details. First, the weather controlling device. Despite the old Earth-like atmosphere, dwellers will need a stable change of weather to grow crops. Then you cover the dome with moving plates. Living in a constant dust might be pretty depressing, so the plates will move in 12-hour patterns. During the daytime, they will turn to enhance the sunlight, while at night, they'll deflect it back, making the sky dark. After that, you travel to both edges of the Terminator Zone and install geothermal plants. On the hot side, the plant will generate energy for all the settlers' needs and take hot water to use in households. On the cold side, the system will make cold water from the ice. The night side can also be used as a giant refrigerator. Dwellers could store things they need frozen here. To make it easier to access, you stretch the dome from edge to edge and create some simple storage facilities where the night begins in earnest. You fly away from Earth at a safe distance in your super modern spaceship, and then bam! You travel faster than the speed of light in interstellar space. How cool! The light from thousands of stars rushes past you. A few minutes, and you're on the other side of the Milky Way and going to work. Such travel has long been common for humans, for you are a member of the human civilization that has conquered the entire galaxy. But it took almost 90 million years to get there. So how did we achieve this? It's like a computer game. In the beginning, we had a fleet of 3 motherships that could travel at 310 miles per second. Each of them had 10 colonization pads. The ship could undock a pad and drop it on the desired planet. We also had 2 speed ships that traveled twice as fast but could only colonize 1 planet. Each colonized planet could send 1 new ship on an expedition. So humanity was able to spread across the galaxy in 90 million years. Most of that time was spent flying from star to star. So the main problem of colonization is speed. Year 2021. Our spaceships can now fly at about 24,850 miles per hour. That's enough speed to travel from New York to Los Angeles in less than 4 minutes. But a trip to neighboring planets like Mars still takes about 7 months. The nearest star to the Sun, Proxima Centauri, is 4.2 light-years away. That means light, the fastest thing in the universe, takes 4.2 years to get there from the Sun. It would take our rocket 73,000 years to get there. That's longer than an advanced human civilization has existed. And our galaxy, the Milky Way, is 105,000 light-years wide. So even traveling at the speed of light would take forever. So, naturally, humanity came up with other ways to travel. Let's move into the future and imagine that we've solved this problem. We started accelerating with microscopic probes propelled by a directional laser beam from Earth. This made it possible to reach speeds of 25% of the speed of light, still very slow. The problem was that nothing that has mass can travel at the speed of light. So we moved on to the Alcubierre drive study. This method doesn't involve moving from point A to point B, but instead compressing the space between those points. Here's a piece of checkered paper. Imagine that you need to travel 3 squares to your destination. Instead of moving in a straight line as fast as possible, we squeeze these squares so that our spaceship is at point B. Now we unsqueeze them back. Space is normalized and we've traveled, in fact, standing still. This is how the Alcubierre drive works. It compresses space in front of the spaceship and expands it behind its tail. So, theoretically, an Alcubierre drive spaceship can move at any speed, even faster than the speed of light. But the amount of energy needed to do this is enormous, and it could be compared to the mass energy of the entire planet of Jupiter. So, while some scientists were working to improve the Alcubierre drive, others were looking inside the most mysterious object in the universe, a black hole. A black hole is something so heavy that it attracts even light and won't let it go. Imagine a circular trampoline. This is our space-time. We put a basketball in its center. The trampoline sags a little bit. Now all the objects we put on the trampoline will roll toward the basketball. That's how gravity works. But if you roll the golf ball past the basketball, it has a chance of getting out of this funnel. Now put a heavy bowling ball in the center of the trampoline. The trampoline sags even more. Now the golf ball will inevitably fall into the funnel with the bowling ball with no chance of escape. That's how a black hole works. And some scientists believe there may be a wormhole at the heart of a black hole. It's a shortcut between point A and point B in the universe. Back to our piece of paper. Instead of moving straight ahead, we fold the piece so that point A is right above point B. Now we make a hole in the paper and move to point B. We unfold it back and voila! You've arrived at your destination. So there's a theory that if a spaceship enters the black hole's gravitational field and withstands the incredible stress there, it can exit to any other point in the universe which that wormhole led to. It might even be another galaxy, or even a parallel universe. Well, our research was successful, and now, looking at a map of the Milky Way, we can get to absolutely anywhere. All that remains is to choose the right place to colonize. There are about 1 billion stars. Around each of them are planets possibly suitable for life. So we need to narrow down the list. First, we look for relatively young stars, almost like our Sun. Near them, a human colony can potentially live for a long time. After that, when a star gets old, it begins to expand and turn red. In the last stages of its life, it can absorb all the planets around it and then explode with such force that the light from the explosion can be seen dozens of light years away. Secondly, the candidate for a human colony must be in the habitable zone of the star. It's a sweet spot, not too far away from and not too close to the star, so that it's not too cold or too hot there. In other words, water on the planet must exist in liquid form. Also, the candidate planet must have a solid surface so that we can live on it. Another important factor is the size of the planet. If it's too big, its gravitational force will press on us. It'll be harder for us to jump, walk, and lift weights on this planet because we're used to the Earth's gravity. But if the planet is too small, we'll feel like real strongmen there. We'll be able to jump high and lift large weights. But then our muscles will lose tone and our health will deteriorate. So we're looking for a planet about the size of Earth. Altogether, we have about 100,000 star systems that fit our parameters, so we start exploring and colonizing. And here's our first target. We've named this planet New Home. Clever. We fire up our faster-than-light engine, and bam, we're there. Even though this planet fits all our criteria, it's still hard to call this place home. Desert landscapes with lots of craters and canyons. We'll have to work hard to make this place look like Earth. The terraforming phase of the planet is about to begin. That means we're going to change the climate and the atmosphere here. We need about 78% nitrogen and 21% oxygen so we can breathe here without spacesuits. So we're launching air plants. Other plants will produce water. We're also building power plants and a plant to produce fuel for our spacecraft. Last but not least, food extraction. Once everything is ready, the colony here can exist on its own. And after several centuries, this planet will be developed and populated enough to send an expedition to colonize neighboring worlds. So, for many millions of years, humanity has been weaving its web in the Milky Way. From one planet to another, we've colonized our galaxy. Humanity is now not only multiplanetary, but also interstellar. The next goal is to make us an intergalactic species. Here's our Milky Way. Zoom out. This is the local group of galaxies. Each one contains millions of stars, candidates for colonization. We have to travel 5 million light-years to get there. Zoom out again. Virgo supercluster. There are about 100 clusters of galaxies similar to our own. Zoom out again. Billion light-years from our home. Neighboring superclusters. Now, each galaxy looks like a little dot, and there are thousands and millions of them. Zoom out even more. 14 billion light-years from Earth. This is our observable universe. There are about 2 trillion galaxies. Even at 1,000 times the speed of light, it would take us billions of years to colonize even 1% of the stars here. But it's not over yet. There's a cold spot on the map of the observable universe. Some scientists think it's a scar from a collision of our universe with a neighboring one. They say the universes could be like bubbles, each containing trillions of galaxies. Once such bubble crashed into ours, and its gravitational force ripped clusters of galaxies out of our universe. If this is true, then parallel universes do exist. Then we have truly endless possibilities for exploration, finding new worlds for humanity, and contact with extraterrestrial civilizations. Sounds like fun.
This may look like a scene from a cool sci-fi movie or an astonishing painting, but it's actually real-life footage of Mars, the very planet known for its bright rust color. Layers of rock and dust cover the planet's surface. They consist of iron-rich minerals. That's why dust on Mars is mostly iron oxide. It floats in the atmosphere and creates an orange-red haze around the planet. But Mars has some even more amazing things, like these blue speckles on its surface. They look like a wind-sculpted sea of dunes around 19 miles wide. Astronauts saw these dunes at the northern polar cap of the planet. That's a region that covers an area approximately as big as Texas. The blue dunes, formed by winds, are shaped like long weaving lines. The winds on Mars are relentless and strong. They turn the barren surface of the planet into terrains of grand beauty. These winds are influenced by many different factors. For example, temperature fluctuations to the way the planet's atmosphere circulates. The atmosphere is thin on Mars. That's the reason liquid water most likely can't exist there for any long period of time. That's why, even though Mars is only half the diameter of our planet, it has the same amount of dry land as Earth. A thin atmosphere is also the reason why wind needs to be exceptionally strong and fast to move the sand and form such shapes as these dunes. Winds usually move at 10 to 20 miles per hour on Mars. Anyway, even though the image looks pretty colorful, the dunes aren't actually blue. The bluish patches represent colder parts, while the warmer regions are yellowish-orange. The images were part of a set of photos released to celebrate the 20th anniversary of Odyssey, a spacecraft orbiting Mars. Mars has numerous sand dunes in different locations all over its surface. Some of them formed 1 billion years ago, like the ones in the Valles Marineris region. They haven't changed because both the atmospheric pressure and wind patterns there have remained the same. But some things do change. For example, some dunes get covered with frost. Here, the main dune has a series of dark patterns. It may be because frost comes and goes, depending on the season. Mars has 4 seasons, just like Earth, but they're twice as long as ours. It's because Mars needs around 2 Earth years to orbit the Sun. Seasons are harsher in the south of the planet than in the north. During southern winter, the planet is farthest away from the Sun. Mars moves pretty slowly, and its orbit is elliptical, different from the orbit of Earth, which is almost circular. Spring on Mars is a season with plenty of dust storms that start in one part of the planet and, eventually, turn into huge storms. They become so large, they blanket the entire planet. Each planet of our solar system has something that makes it special. Jupiter, for example, is not only the largest planet, more than twice as big as all other planets combined, but it also has the biggest ocean in the solar system. Jupiter is made of similar elements to the Sun. They're mostly helium and hydrogen. In the deeper parts of the planet's atmosphere, temperature and pressure increase. That's why the hydrogen gas gets compressed and turns into liquid. That gives Jupiter the biggest ocean, but it's made of hydrogen, not water. There's also a theory that somewhere halfway to Jupiter's center, the pressure increases so much that electrons start getting squeezed out of hydrogen atoms. This allows the liquid to conduct electricity as effectively as most metals do. Jupiter is rotating fast, which creates electrical currents and generates a strong magnetic field. But as a gas giant, the planet doesn't have a firm surface. The planet's swirls and stripes are cold, windy clouds of water and ammonia. Jupiter also has the iconic Great Red Spot, which is an insanely large storm with crimson-colored clouds, spinning counterclockwise. Winds there are way faster than any hurricane on our planet. The Great Red Spot has slightly changed throughout time and is currently bigger than our planet. It's 1.3 times as wide as Earth. Scientists have discovered that its roots extend more than 200 miles into Jupiter's atmosphere. A regular tropical cyclone we see on our planet can only extend 9 miles from the top to the bottom of the storm. These days, the red spot is becoming smaller and taller at the same time. Jupiter also has dozens of moons and a couple of rings, but unlike Saturn's rings, these are quite faint and mostly made of dust, not ice. Also, there's a salty ocean under the surface of Jupiter's biggest moon, Ganymede. It's hidden below a thick icy crust. It's likely to contain more water than all surface water reservoirs we have on Earth combined. The theory says this ocean is around 60 miles deep, 10 times greater than the deepest point of our planet's oceans. Jupiter and Saturn contain 10 million tons of precious stones. The pressure inside these planets' atmospheres can actually turn carbon into small pieces of diamonds. If you put these diamonds under extreme temperatures and pressure, they can melt. This would probably result in some sort of diamond rain. In the beginning, our solar system was just a swirling cloud of gas and dust. It eventually developed into a spinning disk with the central star in the middle. Almost all planets in our solar system move counterclockwise around the Sun. Venus is the only planet that rotates in a clockwise direction, and Uranus rotates on its side. These planets are most likely different because long ago, huge asteroids collided with them and kinda knocked them off their course. There's a chance Venus could be a habitable planet. It's definitely not a place you'd want to live now, not with its sulfuric acid clouds and tremendous atmospheric pressure. It's 90 times greater than that on Earth. Add here insanely high temperatures. The conditions on Venus are very unfavorable for people. At 863 degrees Fahrenheit, Venus is hotter than Mercury, even though it's further away from the Sun. This happens because there's too much carbon dioxide in Venus's atmosphere. It traps heat, which causes the temperature to rise way higher than it's supposed to. But simulations show that around 700 million years ago, Venus might have been a nice place with moderate temperatures and liquid water. Those conditions were slightly similar to those we have on Earth now. Uranus is not a gas giant. It's actually made of ice. The atmosphere contains methane, which makes the planet look blue. It has 27 moons, 2 sets of rings, and lots of ice in its atmosphere. A day on Uranus lasts just a little bit over 17 hours. That's how long it takes the planet to complete a single rotation on its axis. But its tilt is so pronounced that most of the time, either one or the other pole is pointed toward the Sun. That's why the daytime length at the North Pole is almost half a year, and a year on Uranus is as long as 84 years. If you lived on Uranus closer to its North Pole, you'd be able to see the sun in the sky for 42 years. That would be the summer. After this, the sun would go down, and you'd have to live the next 42 years in the darkness. It'd be the winter on the planet. Neptune is the most distant and the smallest of the gas giants. The gravity on the planet is similar to the one we have on Earth, but you wouldn't be able to stand on Neptune's surface. It's gas, not solid land. Triton, the biggest of the planet's moons, orbits Neptune in a very unusual way. It moves backward compared to the rest of the planet's moons. Triton is also slowly spiraling inward toward Neptune. One day, billions of years from now, it's likely to get torn apart by the planet's gravitational forces and become just a ring around Neptune. This ring will continue being pulled inward until it eventually crashes into the planet. Pluto is a dwarf planet, and a year there lasts 248 Earth years. But even though it's not even a planet, Pluto still has several interesting things to offer, like floating mountains. Pluto's nitrogen glaciers carry countless isolated hills, each up to several miles across. They're likely to be fragments of water ice from the dwarf planet's surrounding uplands. Nitrogen ice is denser than water ice, so scientists think water ice hills float in a sea of frozen nitrogen, just like icebergs in the Arctic Ocean here on Earth.
While we may think of ourselves as advanced after catching a glimpse of the 8 planets of our solar system and their 200 moons, we really have little idea of what's out there. So much so that there's speculation that there might be one more planet in our solar system. Scientists call it Planet X or Planet 9. This undiscovered world could be hidden way out past Neptune. Asteroids and dwarf planets in this area have weirdly unexplained altered orbits, and Planet X may be the reason. Tales of this mysterious planet began over 100 years ago with a man called Percival Lowell. Lowell had a great love of space, and aside from having an impressive mustache, he was also super rich. Ooh, that lucky guy. He used his riches to build an observatory in Arizona. He then dedicated it to study the odd motions of Uranus and Neptune. Their gravitational pulls are slower than those of all the other planets in our solar system, almost as if there is a giant hidden object pulling them off course. In 1906, Lowell theorized that there could be another planet out beyond Neptune. It probably caused those strange cosmic happenings. The man called this potential space body Planet X. In 1930, Pluto was discovered by Clyde Tombaugh at Lowell's very own observatory. It finally looked like people had an explanation for the weird orbital patterns. Lowell's team was on cloud 9 after the discovery, but their celebrations were short-lived. Soon, they found out that Pluto is way too small to be having that much of an effect on the surrounding planets. And it was also too far away from them, so it was back to the drawing board. Planet X, if it exists, is 10 times the size of Earth and 4 times its radius. It would take at least 10,000 years for the planet to orbit the Sun, and it would sit over 200 times further out than our home planet. That's 600 astronomical units from the center of the solar system. FYI, an astronomical unit equals the distance between the Earth and the Sun. But while that sounds super far away, it's actually not. The distance between space bodies is usually measured in light years, and an astronomical unit is a much smaller unit of measurement. For context, the most distant thing detected from Earth is the galaxy GNZ11. Cute name, huh? It sits a staggering 32 billion light-years away. Even so, our telescopes can still spot it, and just 1 light-year is the same as 63,241 astronomical units. Woo! So, if our tech can detect a galaxy that's so far away, how have we not been able to uncover Planet X? Well, it's probably down to the fact that it might not even exist. The theory of Planet X was pretty much debunked back in 1989. It was discovered that the mysterious gravitational pulls of Neptune had been a red herring all along. Scientists had massively misjudged just how big Neptune actually was. Voyager 2 visited the planet and discovered its actual size. This new info explained the odd gravitational pulls, meaning they weren't being caused by the so-called Planet X. But that's not where our investigation ends, as the hypothetical ninth planet once again popped up around 10 years ago. While the evidence behind Lowell's theory was wrong, his belief in Planet X may not have been. In 2015, astronomers Michael Brown and Konstantin Batygin discovered that there were, in fact, unexplained gravitational forces at play past Neptune. There are satellites that orbit planets perpendicularly, which doesn't happen anywhere else in our solar system. There's also clusters of asteroids that move in very specific ways, so specific that it's basically impossible that it could be random. Even weirder, there are satellites that travel in completely opposite direction to the Sun, unlike most other things in the solar system. A planetoid called Sedna also appears to be being pulled towards something, along with 6 others, all going in the same direction. And Brown and Batygin aren't just any other stargazers. They're both well-respected scientists at the top of their game. Konstantin Batygin has been named in Forbes as one of 30 scientists who are changing the world. And Mike Brown was the man who rebranded Pluto as a dwarf planet. This means that when these guys say something, it's usually pretty legit, and you should probably listen. But the only way we can really prove Planet X exists is to actually find it, and this has turned out to be pretty difficult. To locate the planet, we'd need to use a method called transit photometry. This is basically where we monitor a whole bunch of stars for a long time and look out for any dips in the light they give off. These dips would likely be caused by a planet getting in the way, and ta-da! The existence of Planet X could be proved. But for this method to work, Earth, the new planet, and the Sun all have to be perfectly aligned. These circumstances are pretty rare, and if these conditions don't exist, the dip in light won't happen. Plus, this method would only really work with planets that are closer to the Sun than our Earth. That's Venus and Mercury. For anything past Earth, this technique is pretty much useless. Another technique we could use is to find the potential planet through a good old-fashioned telescope. But as you can imagine, that's insanely tricky. The furthest object that we've found in our solar system is a planetoid appropriately named Far, Far Out. But that's only 140 AU away from the Sun. That's only like a quarter of the way to Planet X. We can only see an object because of its brightness. The Sun is very visible to us because it emits huge amounts of light. And we can see the Moon because it reflects the Sun's light. Technically, the Moon has no right to appear brighter than everything else in the night sky. It only seems brighter because we're closer to it. The farther away an object is, the less bright it appears to us. The major issue with seeing the theoretical Planet X is that all objects in our solar system get their light from the Sun. They reflect sunlight, and that's why we can see them. Given how far away from the Sun Planet X might be, it makes it nearly impossible to see. And because of its really dim light, to view it, we would require perfect weather conditions as well as an extremely strong telescope. But Brown and Batygin have found the perfect one. The Subaru telescope is located at the top of a dormant volcano in Hawaii. It's huge and is capable of capturing even the weakest light from distant space objects. The issue that we need to figure out is where to point it. Without knowing where Planet X actually is, this basically turns things into a giant guessing game. There are also only around 3 nights every year when the conditions are clear enough to see the hypothetical Planet X. It's difficult, but not impossible. And still, most astronomers have called it a day and agreed that Planet X doesn't exist, stating that it's just a common myth. The most widespread explanation for the weird gravitational pulls is that there's a tiny black hole in our solar system. It's pulling the planets toward us. But don't worry, they say it's not big enough to actually munch on a planet. So Earth is all good, for now. The issue with the black hole theory is that, once again, it's almost impossible for us to track the thing down. While its mass could be as great as that of Planet X, the hole itself would be squished down to the size of an orange. Telescopes wouldn't be of any use. To find it, people would have to look for the gamma rays sent off by objects as they fall into the black hole. Another way we could find it is to release hundreds of tiny spacecraft. They would pass close enough to the hypothetical hole, and when they got pulled toward it, we could probably detect it. But don't count out Brown and Badagin's theory. It's still being documented by NASA. And until we find unmistakable evidence to prove any theories, Planet X might still be out there.
More than 1 million Earths can fit in our sun. New research shows that between 20% to 35% of suns eat their own planets, and a quarter of planetary systems orbiting stars like the sun had a chaotic past. The very thing that gives life can also take it away. All the planets in our solar system revolve around the sun, and they all do it in a somewhat consistent way. It's most likely that they stayed that way ever since they first came into the picture, but not all of them. This chaotic existence means that a solar system had a lot of planets in the litter until the host sun decided to melt them away. Our solar system is panned out perfectly so that no planet's gravity interferes with each other. The gravitational force on Jupiter is a lot tougher than Earth's, which means that if Earth gets close to Jupiter, we'd be another moon for Jupiter. The planet is so big that if Earth were the size of a grape, Jupiter would be the size of a basketball compared to it. Even with the best technology in the world, it's difficult to tell if stars do, in fact, eat their planets. The best way to study this is to observe binary systems. That's just a sciencey way of saying a system with two stars orbiting each other. Usually, the two stars were formed around the same time from the same gases and the same conditions. It means they should contain the same elements, more or less. When you open your eyes in the morning, the sunlight that's been traveling for millions of miles greets you. The closer we get to it, the hotter it is. But the rays traveling from the sun also contain certain chemicals that make it unique. The chemicals that are associated with the sun are light materials like oxygen, carbon, hydrogen, and helium. You can find some other stuff in it too, but these are the main ones. By studying these elements, you can learn the history of a solar system with enough detail to determine if it was chaotic or smooth. Scientists studied 107 binary systems composed of suns like ours by analyzing the light. Since each system contains two suns, they compared and contrasted them to see the differences. They observed the stars with a thin outer layer, having different elements than their companion. All suns contain light elements, but there are some that have rocky elements, like iron, silicon, and titanium near the sun. These elements are associated with rough terrains that you'd find on the surface, but they're out there floating in the middle of space. The thinnest outer layer is especially rich in iron compared to the other layers. Many stars are twins at birth. Even most of the Milky Way stars have a buddy in a binary system. It means our sun is pretty unique for not having a partner. But there are some theories out there that suggest that the sun may have lost its twin in the past. It's around 184 light-years away and is called HD 186302. This might be our lucky star. A stellar nursery is where thousands of stars are born. They're made up of gas and dust that gradually collapse under their own weight. Our sun may have started in such a way 4.6 billion years ago. And when they're mature enough, they go out into the open, usually with their travel buddy. Actually, scientists claim that up to 85% of all stars could be in binary pairs or have more buddies, but over 50% are dual pairs. The only problem is that we can't really see it, since it strayed from its original orbit an eternity ago. But traces of it can be found in the Oort cloud. That's the vast cluster of space consisting of comets, space rocks, and ice in the outer edges of our sun's reach. They float around quite a lot, since they're far off the sun's gravity and can easily be knocked out of their orbit into open space. Flying through such a space is no different than flying through any random void of space. The reason why some of these light elements in space contain rock elements you'd find on the surface of a planet is because the sun knocked them off their orbit and devoured them as they got closer. It also happens when a star becomes too big in its place and starts eating everything around it. According to scientists, if a star eats a planet, it can make it go chaotic and spin so quickly that it eventually rips apart. But don't worry, there's a very low chance of the sun devouring the planet in the near future. Stars are formed when a huge cloud of hydrogen and helium grows until it collapses under its own weight. The pressure increases and reaches extreme heat levels we can't even measure. Eventually, the hydrogen atoms lose their electrons, causing the hydrogen to fuse together and release energy, countering the gravity collapsing. But when the gravitational force overpowers the hydrogen fusion, the star begins to expand and becomes a red giant. And then, after around 1 billion years, the hydrogen in the outer core will go away, leaving plenty of helium hanging around, which will fuse with the rest of the elements around. And once all the helium disappears, gravity will shrink the red giant into a white dwarf. And when it's completely gone, the remains of the star release tons of gas and dust into space. Scientists claim that our sun has between 7 to 8 billion years left before it reaches that stage. But even if that becomes a reality, it wouldn't happen overnight. Something like this takes millions of years to take place. But what if the sun decided to devour us overnight as we speak? The planet would start feeling hot in seconds. Every slight degree change can lead to some catastrophic events. Ice caps can melt in a matter of seconds and flood the coastal lands. Even little islands in remote areas of the world will be submerged. And as it gets hotter, every snow-capped area will melt instantly and turn into desert-like climates. Some places will burn, and your everyday objects will melt on the spot. The Earth's interior will also get hotter, allowing volcanic eruptions to happen across the world. Antarctica will melt from the heat, as well as the volcanoes erupting inside. And just in a matter of minutes, the whole planet will turn into fire and ash before it explodes into tiny bits floating in space, reaching areas we've never even heard of. But no worries, something like this won't really happen. In case the sun knocks us off our rotation, the results would be different. It'll also get hot because the magnetic field around us protects us from the sun's radiation. And once we get knocked out of place, the magnetic field gets tarnished, and the extreme heat from the sun will boil us. The gravitational force will be unstable, so the physics of our everyday life will be chaotic. We'll have to wait 5 billion years from now when the sun turns into a red giant. It'll grow in size, eventually eating up Mercury and Venus. Chances are, Earth will also be on the menu. If Earth were to move only 900,000 miles closer to the sun, then it would be uninhabitable. It may seem like a lot, but it's only 4 times the distance between the Moon and Earth. Detecting the chemical composition of the sun rays in solar systems that are further away could help scientists find other Earth-like planets. Since the atmosphere around these planet-eating stars changes the chemical composition, we can detect which solar systems out there have had a calm past. The main thing we have to observe is if the planets have a healthy orbit cycle. With nothing else getting in the way, we can assume that the planet could follow the same steps as Earth did for humans to be here. But this process will take ages, since there are millions of nearby stars similar to our sun. The odds of finding a planet similar to ours are near impossible at this rate. But if so, then there might be life on those planets. There will be no way of knowing if it's intelligent life, but they might have had the same evolutionary fate as us.
You're gazing up at the night sky. Wow! For much of our history, we've been looking for life among these stars and the planets near them. But space has eyes too, and there's someone out there looking at us, maybe. Scientists claim that at least 29 distant planets may be watching us right now. So comb your hair and smile. We've so far identified at least 1,715 neighboring star systems in the Milky Way that can detect our planet with conventional telescopes. These stars are located in our galaxy. So if they were to point their telescopes at our sun, sooner or later they would see a small dot that passes between our home star and the observer. This is called a transit. It's a method of detecting planets in astronomy. For example, you can observe transit phenomenon right at home with a telescope. You have to point it at the Sun and wait. Then you'll see Mercury. That's the closest planet to the Sun, and now you see it as a small dot. Mercury transit process can last about 5 hours, and this phenomenon happens about 14 times in a century. You'll be able to observe the next transit on November 13, 2032. Mark your calendar. Likewise, you can observe Venus, the second planet from the Sun, but because it's farther away, its transits are less frequent. The last one was in 2004 and 2012. The next pair of transits is expected in 2117 and 2125. Hey, I won't be around then. So these star systems have the opportunity to observe our planet. But long-range telescopes work a little differently. Actually, the observer will not see a black dot with the Sun in the background. The telescope will measure the brightness of our star. When Earth begins its transit between the Sun and the observer, the telescope will record a slight drop in the brightness of the star because our planet is blocking the path of the Sun's rays. Those faraway scientists of extraterrestrial civilizations will be able to calculate this drop in brightness and determine the size of our planet. But not all 1,700-plus star systems may have extraterrestrial life. Scientists have narrowed it down to 29 planets near some of these stars. They're potentially habitable. That means these planets are roughly Earth-like in size and within the habitable zone of their host star. That means they're not too close to the star, so it's not too hot for potential life. The water doesn't evaporate there like in a boiling pot. And they're not too far away, so it's not too cold and the water doesn't freeze into thick sheets of ice. And since water is the basis of life, we can assume that civilization might exist there. Theoretically, these planets could have seen Earth transits in the last 5,000 years. So, while we were building the pyramids of Giza or Stonehenge, an extraterrestrial civilization may have been watching us. One of these planets is only 11 light-years from our home. Near the Ross 128 star, a red dwarf in the constellation Virgo. There's an exoplanet about twice the size of Earth and right in the habitable zone of its host star. Theoretically, the inhabitants of this planet could see Earth transit the Sun on a regular basis for 2,000 years. But about 900 years ago, the planet lost its position and can no longer continue observation. The other planet where Earth can be seen transiting is 12.5 light-years away, near the star called Teegarden. The window for observing our planet will open there in about 29 years. We're betting heavily on the TRAPPIST-1 star system. It hosts at least 7 exoplanets, almost like our solar system. And 4 of them are in the habitable zone of the star. But they won't be able to start observing Earth until 16 centuries from now. But we can try to make contact with these planets right now. They're all close enough to us to pick up our radio signals. Radio waves can travel through space at the speed of light, and our planet has been emitting radio signals continuously since 1895. So we're like noisy neighbors in the radio spectrum. If there's a planet somewhere with an intelligent civilization within 125 light-years of us, our radio noise would have already reached them. The only problem is, it would take about the same time to get a response from that civilization. The other problem with radio is that any civilization uses it for a relatively short period. Even now on Earth, we use Bluetooth and fiber optics more than radio, except for maybe traffic reports. And over time, all the radio noise we create will simply disappear. Also, radio communication assumes that an extraterrestrial civilization is advanced enough to use this technology. But who knows? Maybe there are life forms in space that are really different from ours. Our radio signals already could have reached that planet, but its inhabitants simply aren't capable of receiving them. And the moment these life forms build antennas to receive the signal, we'll no longer emit them. But we don't lose hope, and we even send encrypted radio signals into space to communicate with extraterrestrial civilizations. In 1974, we sent the Arecibo message into interstellar space. If some civilization can decipher it, they'll get a rectangle like this. It has all the information about humanity. At the top is our number system, then the atomic numbers, and then our DNA, which is pictured below. Then a human being itself, of course. Below is a diagram of our solar system. Earth, the third planet from the Sun, is slightly elevated. This is how the extraterrestrial civilization will understand which planet this message came from. Below is a diagram of the Arecibo radio telescope itself. Another option how to deliver a message to a distant planet is to literally send a mail delivery there. It could be a space probe. And we've already done that. These are Voyagers 1 and 2. They were launched in 1977 and are still operational. In 2012, Voyager 1 became the first ever human-made object in interstellar space. It travels to distant stars and carries a message written on a golden record. The disk contains greetings in 55 Earth languages, a lot of music from different parts of our planet, different sounds like ocean noise, human voices, and animal sounds. In addition, there are 116 images on the record. These are pictures of people and earthly landscapes. In these pictures, there's information about the Sun and our DNA. The record case contains instructions and a needle to play the record. There's also a map of our galaxy's pulsars so that astronomers from an extraterrestrial civilization can find our solar system. The main disadvantage of sending a message this way is time. Voyager 1 will reach its first stop, the Gliese 445 star, in 40,000 years. Voyager 2 will reach the Ross 248 star in 42,000 years. And in about 296,000 years, it'll pass Sirius, the brightest star in the night sky. I can't wait. Also, an extraterrestrial civilization can detect us with calculations and formulas. All it takes is a little observation of the Sun. In star systems with planets, the host star doesn't stand still. It rotates around a small orbit. This is because the heavy star attracts the planet, but the planet also has its own gravity and resists. This shifts the star a little and causes it to orbit around. An extraterrestrial civilization can calculate this shift of the Sun and determine the mass of the planets near the star. Using such a method, astronomers were able to find 548 exoplanets. Now suppose we made contact with an extraterrestrial civilization near the closest star, Proxima Centauri. There's indeed an exoplanet there, but radiation from the host star would destroy any life forms. But imagine we still got a return signal. It would be the slowest chat in history, because our message would take 4.2 years to reach the planet, and we'd have to wait another 4.2 years to get a response. And so we arranged to meet. This civilization doesn't know how to fly into space. So we have to take the first step. Although Proxima Centauri is the closest star to our solar system, it takes about 73,000 years to travel there by conventional rocket. So we have to learn to travel at the speed of light. But even then, it would take 4.2 years to travel there. Imagine if we found extraterrestrial life on the other side of the Milky Way. Our galaxy is 100,000 light-years wide. So the journey from edge to edge would take 100 millennia. So, we either have to cheat the laws of physics or transfer all of human civilization to a giant spaceship that will travel from star to star for thousands of years. And when it launches from Earth, only the great and many more greats of the first crew will be able to see another star system from the spaceship portal. Hey, can you move your head? I'm trying to see out the window. Earth. Home. The third blue rock from the Sun. The only known planet where life can thrive. We have around 78% nitrogen, 21% oxygen, and 1% argon, water vapor, and carbon dioxide, give or take. The perfect balance to support our respiration. The troposphere is the lowest and densest part of Earth's atmosphere, 5 to 9 miles thick. It's the part of the atmosphere that keeps changing our weather. For any life to exist, we would need this atmosphere and the same combination of gases to breathe. If all the planets in our solar system were combined to become a mega-Earth, then humans wouldn't have evolved the way we are today, and we'd have a very different planet. If we take the landscape of Mars, we'll only have solid land without large bodies of water. Earth is the only planet in our solar system with bodies of water. One of the first wonders to see will be Olympus Mons, the largest volcano in the solar system. It towers Mount Everest by a long shot at 78,000 feet above the ground. Velis Marineris is a group of canyons that make the Grand Canyon in the U.S. feel like a average one. This wonder stretches for almost 2,500 miles and goes more than 4 miles deep. On top of these epic terrains, there's plenty of other grand-scale locations on Mars that are way bigger than the ones on Earth. The planet might be as large as Jupiter. If the Earth were the size of a grape, then Jupiter would be the size of a basketball. We'd have the size of Jupiter and the rings of Saturn floating around us. The rings may seem like some large chunks of rock in the air, but they're actually ice particles and chunks of iced rocks. They range from the size of pebbles to car-sized ones. Saturn's rings are supported by the unique gravity in the region. With a lot of these ice rocks floating in the sky, there won't be much sunlight entering the planet, which means the planet will always be colder than usual. Not to mention the many moons it has. Our megaplanet could also have many moons circling above us, contributing to the tidal waves. Jupiter is known for the red spot, a place twice the size of Earth that has hurricane-like storms that have been going on for hundreds of years. The people of Mega-Earth will settle far away from it. Mercury is a planet but looks like the Moon due to all the craters lying around. That's because of many asteroids and comets striking it over billions of years. But the landscape here mainly consists of mountains, highlands, cliffs, and valleys. The Caloris Basin is almost 1,000 miles wide. They believe it was formed by a comet. The deserts on Earth are mainly hot and consist of dunes of sand, but they also have flat plains and small hills. The largest desert in the world is the whole Antarctic continent. Mercury has no atmosphere to trap any heat, so it gets really hot when the sun is facing it and freezing cold when the planet turns away from it. On this combined mega-Earth, the desert will most likely have a similar landscape to that of Mercury. The animals living here will probably be something like giant scorpions and desert snakes that soak in some sun during the day and go out hunting at night. But the soaring day temperatures would melt anyone walking. And even though Mercury is the closest planet to the Sun, it's not the hottest. Venus has temperatures of nearly 900 degrees Fahrenheit. Scientists believe that the lands here are flat because of the extreme temperatures, but it's not all flat, with some volcanoes and highland areas. We can probably find this terrain and climate near the equator, since it's always hot there. Humans can't live there unless they build special domes to sustain life. But since the planet is now huge, not all its territory needs to be populated. Some areas will have the proper atmosphere for breathing, but some places might not have such luxuries. Over at the poles, the climate will most likely mimic Pluto's, even though it's not technically a planet anymore. In 2006, they officially declared it a dwarf planet, and it's even smaller than the Moon. There's not much known about this little mini floating rock, except that it's composed of around 70% rock and 30% ice. Scientists believe that a part of its surface is covered in frozen nitrogen, solid methane, and carbon dioxide. Since the megaplanet is huge, gravity might be quite strong here. Jupiter's gravity is enough to double your weight. Humans will most likely be really tall and mega-sized to match the big planet. Even the oceans will be huge. Our oceans will look like little lakes compared to what Mega-Earth has in store for us. Humans need something close to 24 hours in a single day. Our bodies adjusted to it quite well, but it wouldn't affect us too much if the day had a few extra hours or a few hours less. We can't live on any other planet without wearing the proper gear. We wouldn't last more than a few seconds in places like Jupiter, Neptune, and Saturn. It's possible to last as long as you can hold your breath on Mars. The atmosphere is thin and the gravity is similar to ours, but you might freeze. Even though it's a red planet, it's actually very cold and has ice caps in the poles covered with carbon dioxide. The same's true for Mercury. You can only last there as long as you can hold your breath and be in the sweet spot between the sunrise and the sunset. Ancient civilizations wouldn't have been as diverse as they were on Earth, since the extreme terrains and conditions wouldn't have allowed for discovery and training. But eventually, as humans developed special technologies for certain areas, different cultures would emerge. Many animals would also evolve in specific and unique ways, but because of the planet's enormous size, isolation, and being on top of the food chain would let certain animals be around since the beginning of the planet without evolving. So it's possible that this mega-Earth might have ancient dinosaurs roaming around, and they'd be even bigger than the ones on Earth. And even though there's a high chance that some humans might be physically different than each other, there might even be more than one species of humans living on opposite ends of the planet. Because of the isolation, they evolved in their own ways according to their surroundings. Over the centuries, technological advancements would spread different cultures around, and we'd be more open to each other. Neanderthals and Homo sapiens once lived side by side and were considered as the two species of humans. Neanderthals were intelligent and used tools for hunting and drawing. Homo sapiens were survivors and wandered around to discover new land. There could be two dominant human species and other minor ones that live in certain areas on Mega-Earth. They'd be bigger, tougher, and faster than us. The ones who live by the trees would have elongated limbs to stretch out and swing from tree to tree. The ones that live in savannas will probably run really fast and have long legs for that. Countries and cities will be bigger than what we have on regular Earth. A country can be as big as Earth itself. The human population can reach tens of billions. Special transportation technology might be invented for people to travel from one continent to another. Covering those distances can take months or even years if using regular aircraft. High-speed trains that travel so fast over land and rocket-like planes going through the sky. Traveling through oceans will require extremely sturdy ships. Traveling through the Atlantic Ocean is already scary for many, so imagine going on a voyage across a body of water that's potentially 8 times the size of Earth. We're going to need a bigger boat. There'll be areas to avoid, like the red spot with its perpetual storms raging on, but the tourist industry might have some room for anyone who wants to see it. Living on such a huge planet is unlikely going to become a reality for most of us anytime soon. But scientists are already discussing moving to other planets to find a new home for humans. The Milky Way is one of the biggest mysteries out there, literally. It's hard to figure out how big our home galaxy is, and one of the main reasons is because we live in it. Think of it as walking around a mall. You can tell it's big, but you can't be certain until you actually see it from a bird's eye view. The Milky Way consists of billions of distant stars that look like a string of lights from afar. So you just need to measure the distance between these stars and voila, you have the answer. Not really. I might have forgotten to mention opaque clouds of dust blocking your view. Some scientists were stubborn enough to run computer models of how galaxies form and evolve. There's a halo around our galaxy, so the scientists wanted to see if there was some sort of a dead end in the Milky Way. They found out that the Milky Way spreads for 100,000 light-years away from its center. It likely means that the entire galaxy is around 200,000 light-years across. The problem with this estimation is that halos don't tend to have some final border since they simply fade away. It's like pointing a flashlight and trying to see precisely where the light ends. In 2013, the Hubble Space Telescope captured an image of something 25 million light-years away. It turned out to be a spiral galaxy, later called ESO 3738, with at least 7 other galactic neighbors. And this galaxy is as thin as a pancake, a very shiny pancake. The telescope also took a photo of another galaxy cluster 65 million light-years away. It was called IC 335. It's another glorious glittering pancake floating in the vastness of space. The images the telescope took aren't the most accurate. It's hard to tell what exactly you're looking at. These disk galaxies have lots of dust clouds that can stretch for hundreds of light years across. They're mainly located near the centers of galaxies and are invisible in regular light, but they can be detected with the help of a blue filter. Anyway, this IC 335 galaxy is an oval disk with huge clouds of gas and dust. This means stars constantly appear there. But not all galaxies create stars. A galaxy is born as a giant ball of slowly rotating gas that is steadily collapsing in on itself. As it starts spinning faster and faster, the pancake shape is formed. Ooh, pass me the syrup. It's like spinning pizza dough in the air after rolling it into a ball. The topping is stars, and the sauce is clouds of dust and gas. Are you getting hungry like me? Some galaxies can lose their gas and dust if they become part of a galaxy cluster. Then all these mini-galaxies orbit their common center of mass, with gas separating them. When a disk galaxy dashes through them like a speeding train, the pressure can blow away this dust and gas. From far away, it looks like you're staring at a DVD you're about to play. But if you traveled millions of light years to get a closer look, you'd see a dim disk filled with stars. You wouldn't even be able to tell you're inside it. You'd also see a bright blob of dust left by the red giants in the middle of the galaxy. Red giants are massive and very bright stars with low surface temperatures. But the images of these galaxies don't actually show us their real color. Cameras make up some of these hues so that you don't have to look at something fuzzy or grainy. People don't actually know the real colors of distant galaxies. Our galaxy has a lot of gas inside, like me, so we don't need to expect our home to dry up anytime soon. In fact, the Milky Way still produces new stars, around 7 a year. But some galaxies fade out when they can no longer create stars. In the industry, they call it strangulation, and it happens when galaxies run out of gas, which means there's no more new material that can be used for star making. Gas and dust aren't the only things you can find in a galaxy. Just like a magician pulling a rabbit, flowers, or other things out of their magic hat, galaxies have other surprises, like planets, those balls of matter spinning around themselves and around other things. Well, technically, planets are far from being perfectly round in shape, but they aren't also flat like spiral galaxies. It's mostly because of gravity. Its force is so strong that a planet pulls everything towards its center, taking the shape of a sphere. In the process, all the edges and anything else that might stick out gets smoothed out. But the smaller a space body is, the less round it is. Take a comet. It doesn't always have a smooth surface. It's small, and therefore, its edges are rugged and pointy. Given the size of Earth, it's safe to say the gravity is strong here compared to that of the Moon or any smaller-sized space object. And because of our planet's constant rotation, there's an outward bulge on Earth. This tug-of-war between the gravity pulling inward and the planet's spin doesn't allow Earth to be a perfect ball. On top of Earth not being a perfect sphere, the planet is also tilted. This design flaw is responsible for the seasons we have. This tilt could happen because millions of years after Earth was formed, it probably collided with a protoplanet, a large space body developing into a planet. Venus is unique because it rotates backward compared to the rest of its peers. If you were standing on Venus, the hottest planet in our solar system, you'd see the sun rise in the west and set in the east. But you'd have to make it on time to observe this phenomenon. A day on Venus lasts for more than 240 Earth days. For a long time, scientists believed that the sun's strong pull on Venus was responsible for such a long day. But new theory claims that Venus used to spin just like Earth and the rest of the planets. But at one point, it just flipped its axis 180 degrees. It doesn't mean the planet abruptly stopped halfway through the rotation and started to move backward. One theory suggests that a large comet or object struck the planet in the past. This might have caused it to change the direction of its rotation, but many scientists doubt this theory. If you observe the moon for some time, you may notice that it's the same face staring at you every night. The truth is that the moon does rotate, but very slowly. It takes our planet's natural satellite 27 Earth days to rotate around its axis. Plus, the moon rotates at the same rate that it orbits Earth. The side we always see is called the near side of the moon, and the side that's not facing us is, you guessed it, the far side of the moon. It also has the nickname the dark side of the moon. Uranus's rotation axis is 98 degrees relative to the plane of the solar system. which basically means that the planet spins on its side. For a while, scientists believed that a large object firing through space knocked into Uranus, causing it to tilt. But here's one problem. Uranus's moons are covered in ice. A collision so powerful that it made the planet tilt would have resulted in disrupting the moon's movement and their position. But they seem relatively untouched, and all the ice covering them is still intact. But any major changes happening with Uranus would have generated enough energy to melt the ice. Another reason for Uranus's strange position might be its rings. Yup, Uranus has rings just like Saturn, except they're lighter and fainter. Saturn's rings are mostly billions of chunks of ice and rock floating in orbit. Some particles can be the size of a pebble, while others can reach the size of a house. Wow. Other particles are broken up comets, asteroids, and moons torn apart by Saturn's gravity. If you observe the rings from afar, they look like colorful stripes made up of thousands of different streaks, but there are actually only 8 layers of rings. Uranus might have had rings that were just as glorious as Saturn's around 4.5 billion years ago. The balance between Saturn's gravity and its rings might be responsible for keeping the planet upright so that it doesn't tilt over. If Uranus had the same rings, they could prevent the planet from toppling over. The way to solve Uranus's tilting problem might be for the planet to get its rings back. They would help Uranus keep its balance. On the other hand, hey, we like it just the way it is.
Scientists keep finding new planets they call super-Earths. It's a class of more massive planets than Earth, but way lighter than ice giants, such as Uranus and Neptune. Super-Earths can be made of rock, gas, or a combination of these two. They are often twice or even up to 10 times bigger than the Earth. They're interesting to study, but kinda too far away from us. They're pretty common outside of our solar system, together with other interesting planets like mini Neptunes. Those can also be gas dwarfs, ice giants, or huge rocky bodies. But again, we don't have anything like that. But something we do have that those other solar systems don't? Jupiter. It's the biggest and heaviest object that orbits our sun. This king of planets possesses a powerful force to dominate our solar system. Jupiter is notorious for eating planets. A protoplanet slammed into it about 4.5 billion years ago, when Jupiter was still a young planet in its early stages. This protoplanet was 10 times heavier than Earth and was made of ice and rock. The collision was huge. Jupiter's core broke apart, and helium and hydrogen mixed with denser materials. Through time, the heavy materials settled back into the dense core, which is what we see today. And if it swallowed a planet before, it might keep doing it as well. We suspect our solar system used to have many more large planets than it has now. For example, it's kinda empty around Mercury today. Similar areas around many other central stars are definitely more packed with intermediate mass planets, with the size between Earth and Neptune. Our solar system was a chaotic place at its beginnings. Young stars were surrounded by swirling disks of dust and gas, and planets would form out of that debris, something like trees when they're springing up from the ground. Small rocky planets would form in the strong heat and light close to stars, while gas giants would form farther out, where temperatures were lower, which means they could preserve more gassy materials. And even though planets in our solar system seem pretty stable and peaceful today, following their orbit, they weren't that calm before. Some planets didn't have a circular orbit. They had oblong, more eccentric paths. It took them swinging first toward their stars and then farther away. It was like they had been thrown off kilter by the gravity of other planets on their way. There's something called the grand tack theory. It explains things happening in the first few million years when our solar system was forming. At some point, Jupiter, one of the key players here, may have been pulled in closer by our central star. After that, it went back and took a huge cloud of debris. It was like a sailboat when it tacks around a buoy. This kind of messed with planets that were in the process of formation. After Saturn was fully formed, our close neighbors in the solar system cleared out a little. But if the idea about grand tack is correct, Jupiter had grabbed everything in its way, and its migrations had caused more collisions in this area. Jupiter might have delivered some of the water that now fills the oceans we have on our planet. It shepherds plenty of asteroids. From time to time, it sends some whizzing into interstellar space, or amongst the planets in our solar system. It may have even taken part in the dinosaur extinction 66 million years ago. When the huge space rock hit the Earth, it left a crater off the coast of the Yucatan Peninsula in Mexico. It all caused earthquakes, volcanic eruptions, and tsunamis that made a huge impact on all animal and plant life on Earth. No one knows where it came from. We're not even sure if it was an asteroid or a comet. One theory says it may have been a comet that came from the Oort cloud, which is made of icy debris and is located somewhere at the edge of our solar system. It could have been bumped off course by Jupiter and its powerful gravitational force. This way, our solar system was like a pinball machine, where Jupiter, the biggest planet, kicks incoming comets into orbits that send them closer to the Sun. When these comets are near the Sun, they can go through strong tidal forces that break them apart and eventually create shrapnel-like pieces of a comet. That event was a point when our mammalian ancestors started to rule. That means without Jupiter, there might not be us either, nor the Earth. It seemed like our biggest planet came swinging in, destroyed older planets, and cleared the way for smaller worlds like ours. Jupiter may have been the reason why we can't find Planet 9 right now. Scientists believe it exists, and they think it could be hiding somewhere beyond Neptune, but not Pluto. There are 3 zones in our solar system: the inner planets, outer planets, and whatever there is beyond. The mysterious planet could be the size of the Earth or Mars. It swirled among the gas giants before they eventually swept it toward the outer parts of our solar system, or even somewhere into deep space. Jupiter has stripes because of differences in temperature, atmospheric gas, and chemical composition. Scientists used to think the only reason for these different colors was the mighty atmospheric wind and material circulating between layers of the atmosphere. Now we know the light-colored stripes, or so-called zones, show us where the gas rises. When the stripes are dark-colored, they're called belts and can tell us where gas is sinking. Jupiter's moons could also be why the planet is stripy, because they're tugging on its atmospheric convection cells. At the center of Jupiter, there's a dense liquid core made of helium and metallic hydrogen, together with dissolved heavier elements. As we go further from its center, the temperature and pressure inside the planet drop off. That way, the liquid interior gives way to gases from the atmosphere. Again, mostly helium and hydrogen. No one knows how deep this liquid-gas boundary lies, but the planet is probably fully liquid a couple of thousand miles under its cloud tops. Jupiter would still be bigger than some other giants, like Saturn, if we could strip its gases. Jupiter is sometimes even called a failed star, although that's not quite correct. It's mostly made of hydrogen, like regular stars, but it's still not massive enough to start thermonuclear reactions in its core, which would eventually turn it into a real star. In theory, every object could be turned into a star if you only add enough matter to it. If there's enough mass, the temperature and internal pressure will increase and start thermonuclear reactions. So, to turn Jupiter into a star, such as the Sun, you'd have to make it 1,000 times more massive. But to form a cooler red dwarf, you'd only need 80 Jupiter masses more. That way, Jupiter won't spontaneously become a new star of our solar system. But if many space objects with similar mass collide with it, or in other words, if Jupiter eats them, then maybe. You never know. But in theory, if it could become a massive star, it would have stopped other planets from forming in stable orbits. It would have also increased the radiation that the surface of those planets get, which is why it would be really hard for life to develop in our solar system. Jupiter is the planet that spins the fastest in our solar system. It only needs 10 hours to make a full rotation on its axis, even though it's huge, more than 300 times bigger than the Earth, and 2.5 times more massive than the rest of the planets in our entire solar system together. But if it got more massive, it would shrink. More mass would make Jupiter denser, which means it would begin pulling in on itself. So it could get 4 times its mass and would still be the same size. Imagine flying in a spacecraft in a cloud of asteroids at high speed. You dodge one more, and then hit the gas pedal to the floor and crash into an asteroid at full speed on purpose. This is exactly what NASA is going to do in the near future. The entire mission will begin at Vandenberg Air Force Base in California on November 24th. Let's follow it step by step. So, the Falcon 9 booster rocket is already on the launch pad. It's as tall as a 22-story building, or 11 giraffes, and it can get about 8 tons of cargo into orbit. So you could send a big elephant into space, and a supply of food for it. Countdown. 3, 2, 1, ignition! Smoke clouds everywhere, and the rocket begins to gain altitude. 9 engines are working at full power to accelerate the rocket. At its peak, it reaches speeds 10 times faster than the speed of sound. And then, the rocket engines shut down, and the rocket's first stage undocks to return to Earth. A couple of seconds later, the second stage receives the ignition command. It turns on its one engine and climbs even higher to orbit. The cargo capsule then opens and releases the DART spacecraft. DART stands for Double Asteroid Redirection Test. Once released, the spaceship deploys 2 large solar panels. It'll convert solar energy into electrical energy to power a revolutionary ion engine. Conventional engines create thrust by burning tons of fuel and ejecting it outward. The rocket itself is essentially pushing off the emitted gases. The ion engine will not burn fuel. It'll use a strong electric field to accelerate the ionized gas. Like conventional rockets, it'll eject this gas and create thrust by repelling it. And though the ion engine produces less thrust, it can accelerate the spacecraft to higher speeds. So regular rocket engines have an excellent performance on the road. They push the pedal to the metal, burning a bunch of fuel, while the ion engine slowly accelerates. But when a conventional rocket needs to make a refueling stop, the ion spacecraft will whiz past the regular one at insane speeds. So the DART spacecraft begins its year-long journey. By comparison, a flight to Mars would take about 7 months. Fast forward 1 year ahead, and we've arrived. This is the asteroid Didymos. The far point of its orbit is 2 astronomical units from our star. That's 2 Earth-Sun distances. At this point, the Sun begins to pull the asteroid back, and then it approaches the closest point to the star, 1 Earth-Sun distance. That is, its orbit lies very close to the orbit of our planet. Didymos made its closest approach to Earth at a distance of about 4.8 million miles. That's 20 times farther than the Moon's orbit. It takes 770 days to complete one such revolution around the Sun. So, Didymos is not considered a hazardous asteroid, but in the future, it'll approach the Earth even closer, and the consequences of a collision with it could be catastrophic, given its size. It's bigger than 2 Empire State Buildings, and it rotates at a rate of 1 revolution in 2 hours and 15 minutes, so it has a tremendous amount of energy. Plus, it has an asteroid companion. It's a small pebble 520 feet wide. It's like 12 school buses or 10 train cars. Its orbital period, that is, the time it takes the pebble to make a complete circle around the asteroid, is about 11.9 hours. NASA believes that asteroids up to 80 feet wide are likely to burn up completely in our atmosphere due to friction with the air, so they're not hazardous. Asteroids between 80 feet and half a mile in size will not burn completely and could cause severe damage. And asteroids over half a mile have the potential to wipe out large cities or even entire states. In that sense, we can consider Didymos potentially hazardous. So we're going to test one way of defending against asteroids on it: kinetic impact. That's why we sent DART here. So our spacecraft is going to hit an asteroid, only not its main body, but its little companion. DART is already moving toward it at about 4 miles per second. At that speed, a trip from New York to Washington, D.C. would take less than a minute, and a trip across the United States from coast to coast would take about 10 minutes. DART is getting close. 3 seconds to impact. 2, 1, BAM! The spacecraft crashes into the asteroid at full speed. What are your predictions? Asteroid explodes and is blown to pieces? Or asteroid flies off the main body into space like a billiard ball? Well, scientists predict that this collision will reduce the speed of this small asteroid by a fraction of a percent, but it'll still be enough to reduce its orbital period by a few minutes. Then our telescopes on Earth will be able to study the effects of the collision in more detail. And to learn even more, we'll send another spacecraft to Didymos on another mission. This is Hera. It'll be launched in 2024 and is scheduled to arrive at Didymos around 2027. This spacecraft will carry a bunch of research equipment to assess the collision damage done by DART. When it arrives, Hera will take many pictures of the small asteroid, including a fresh impact crater. Hera will also be carrying 2 CubeSats. These are miniature space probes, smaller than a shoebox. It'll launch these mini satellites, and they will make an even closer approach to the asteroid. They will study this space rock for 3 to 6 months. At the end of the mission, one of them will attempt to land on the asteroid's surface to learn even more about its composition and internal structure. It's also possible Hera will carry a mini impactor. This thing will have to make another impact on the asteroid. Then scientists will be able to evaluate the difference in impacts with a large spacecraft and a small one, and understand how we can defend against asteroids in the future. In theory, we don't need to send a giant rocket to a dangerous asteroid to destroy it. A single strike might be enough to shift the trajectory of the asteroid slightly. On a cosmic scale, changing the trajectory, even by a fraction, would dramatically change the asteroid's finish point. But kinetic impact is not the only way to deal with hazardous asteroids. Check out the gravity tractor. For this technique, we need to send a spacecraft toward the asteroid too. Only it won't crash into it. It'll have to go into its orbit. Any asteroid has a force of attraction, and it'll pull the spacecraft toward it. But the spacecraft's engines will keep it at the same altitude, so the asteroid itself will start attracting to the spacecraft. This method is reliable enough, but it takes a long time. And it'll only work if we detect a potentially hazardous asteroid many years before it arrives at Earth. We should have enough time to send a spacecraft to the asteroid and then carry out an asteroid tractor technique. The other option is a laser. When an asteroid is found, we need to aim a powerful laser beam at it. It'll heat up a certain point on the asteroid, causing the material there to evaporate. This is where physics comes into play. The material on the asteroid evaporates upwards. It makes the asteroid itself move downward. Just like our rocket engines work, the burning fuel is ejected one way and the spacecraft moves the other. We can also use solar power instead of lasers. To do that, we need to build a big space station, which would be equipped with a lot of magnifying glasses. Have you ever tried to burn letters on a wooden surface with a magnifying glass? Well, we'd be doing the same thing, but with an asteroid. The space station will have to focus lots of the sun's rays into one point on the asteroid. Again, the material evaporates because of the high temperature, and this causes the asteroid to change its trajectory slightly so that it flies past our planet. How about foil? That's right, we can avoid a collision with an asteroid by using ordinary foil. We would have to wrap the asteroid in the same reflective material. Then the asteroid won't absorb the sun's rays, but will instead reflect them. This creates a little pressure on the surface of the asteroid. It's as if the sun's rays are pushing the asteroid, and it'll be able to change its trajectory. And not the most obvious but reliable option is conventional rocket engines. We can put several powerful engines on the asteroid. This would create thrust and change the trajectory of the asteroid. And if there are enough engines, we can even take control of the asteroid. So when a bigger space rock appears on the horizon, we'll turn on our engines and point the asteroid straight at it. Such a collision can completely destroy even a very large asteroid. And it would make for one epic light show.
So check this out. Astronomers have discovered an exoplanet they're calling Super Saturn. It's got rings over an AU wide. An AU is the astronomical unit, the distance between the Sun to the Earth. That's an incredibly huge ring system, hence its name. Super Saturn is being called Mamajek's object after the astronomer who led the team to whom we owe the discovery. Professor Eric Mamajek of Rochester University in New York found Super Saturn while scouring through data downloaded from wide-angle transit observations. WASP is the acronym for Wide Angle Search for Exoplanets. It's an ingenious project developed in the year 2000 by astronomers at Queen's University in Belfast, Northern Ireland, and St Andrews University in Scotland. Using 4 telescopes, the CCD video cameras on the scopes record the slight dimming of starlight caused by objects passing in front of stars. This is called the transit method of exoplanet detection. So, for example, the planet Venus transits across our view of the Sun every couple hundred years. A black dot, the silhouette of Venus, is visible, crossing in front of the Sun as Venus passes between our line of sight and the Sun. This tiny eclipse causes the amount of sunlight coming to Earth to be reduced by a minuscule amount, also known as teeny tiny. The same is true for all the stars in the Milky Way that have planets going around them. Exoplanetary transits in front of stars must be in direct line of sight with Earth for the starlight to be dimmed. Such transits do not occur very often. That's why thousands of stars must be looked at simultaneously for as long of a duration as possible, between 4 and 8 hours a night. WASP was created to stare continuously at as wide of a range of stars as possible. Maybe one of them would show an exoplanet transit. That translates into a lot of data being produced, about 40 gigabytes per viewing session. Computer scientists at Leicester University in England developed a computer program to store the data and generate photometric graphs of the light intensity of each star. Open University, also in England, joined the WASP project, took this data, and made it available for research by astronomers worldwide. The graphs of the intensity of starlight show that changes in its brightness are called light curves. These graphs have two axes. One is in the timeline axis, the other one is the intensity of light. As the object, considered an exoplanet, though it could also be a brown dwarf star, crosses in front of the star, the timeline axis keeps track of how swiftly it is moving. It tells us how close the object is to the star, while the brightness axis keeps track of how much the starlight dims. This way, we can find out how large the object is. Now, obviously, big objects will dim the light more and be easier to detect. At present, Earth-based equipment is not sensitive enough to measure the dimming caused by planets as small as Earth. Neptune's size and larger ones are the limit for WASP. However, the James Webb Space Telescope, which is now in operation, has a much greater sensitivity and will be able to resolve the transits of Earth-sized exoplanets. Now, I know you want me to get to Super Saturn, but there's something else you should be familiar with before we get there. If the exoplanet has an atmosphere, or, in the case of Super Saturn, a ring system, the starlight from the star the planet is transiting will shine through the atmosphere or ring system, and that can be detected too. The light curve will show less dimming in the photometric data, because not all the starlight is being blocked. Some light is still getting through the atmosphere or rings. This is important because it gives astronomers a reading of the atmosphere. The James Webb Space Telescope is fitted with spectroscopes that can determine the gas content of the transiting exoplanet atmospheres: oxygen, methane, carbon, etc. The WASP project has been really catching on. There's a Super WASP project now consisting of WASP North and a WASP South. One looks at the sky above the northern hemisphere, the other looks at the sky above the southern hemisphere. There's also a Next Generation Transit Survey, NGTS, based on the WASP project. It's automated, so astronomers don't have to stay up all night sipping coffee, but they can if they want to. Located at the European Southern Observatory in the Atacama Desert in Chile, the NGTS scans millions of stars and has discovered over 100 exoplanets, down to a size as small as 3 times the size of Earth. NGTS has started a Planet Hunters Club on social media. Citizen scientists can search the online database of light curves and perhaps discover your very own exoplanet. What had been a strictly British effort started by 1 or 2 astronomers is now a worldwide phenomenon. With the ability to read the spectroscopic signatures of atmospheric gases during exoplanet transits, a new idea emerged: technosignatures. That is, specifically identifying gases in exoplanet atmospheres that are produced by civilizations. The James Webb Space Telescope can do this. Gases from pollution, such as chlorofluorocarbons (CFCs), can be seen spectroscopically if present. Tritium from fusion reactions, if they have them, can also be detected, along with heat patterns from cities on the planet's surfaces. Technosignatures is a recent concept that originated after the WASP project started. Who knows what it will turn up? Now, let's get back to Super Saturn. The star that Super Saturn orbits is J1407, a small, dim, sun-like pre-main sequence star of the 13th magnitude. Huh? Well, the human eye can only see stars to about the 6th magnitude, and each magnitude is 2.5 times dimmer than the previous one. So it's not an exceptional star, just another telescopic star out there in the Scorpius-Centaur region of the night sky. J1407 is a young star that hasn't yet settled into its stable, long-duration phase. This is important because Super Saturn, officially J1407b, is showing signs of having a ring system in an early stage of development. Super Saturn's light curve was tucked away in the mountain of data from the Super-WASP project. Professor Eric Mamajek and his associate Matthew Kenworthy of Leicester University studied the data thoroughly and produced a detailed report on it. Knowledge depends on good data. The horizontal axis of J1407b's light curve, the time axis, is what's causing all the hubbub. It took Super Saturn weeks to transit across in front of its parent star, 56 days to be exact. Planetary ring systems that we are familiar with in our solar system orbit right around the equators of the gas giant planets and are very thin, from only a few meters thick down to a few centimeters. In a telescope, Saturn's rings will seem to disappear when the planet is at zero inclination toward Earth. Saturn must be inclined at an angle in relation to Earth to see Saturn's beautiful ring system. It's something everyone should make a point of seeing: Saturn in a telescope. If Super Saturn's rings blocked most of the light from J1407 for 56 days, it means that the planet had to be orbiting at a steep inclination to its star. If it were at zero inclination, we wouldn't see the rings blocking any light. Therefore, the orbital time could be determined, 10 years minimum to 200 years if the orbit is highly elliptical. The superplanet itself is calculated to be 24 times the mass of Jupiter, which means that if it is gaseous, it could be a brown dwarf star. Super Saturn appears to have a Mars-sized object orbiting around it, because there is a huge gap in the rings that was most probably cleared out by a large object. The Cassini division in the rings of Saturn is where the moon Mimas has cleared out a path through Saturn's rings. The light curve of Super Saturn has only been observed once. All the exoplanet detection systems are keeping an eye out for it to come back around J1407. No one knows when that will occur. Some astronomers have suggested that J1407b is a brown dwarf star system in itself, merely passing in front of, but not connected to, star J1407. An orbital reappearance of Super Saturn would disprove that conjecture. The center region of Super Saturn blocked out all the light from its primary star. This is what indicates that the ring system is new and in an early developmental phase. Over time, the very dense ring mass close to the planet is expected to thin as all this matter gets absorbed into the planet or ejected into space. This is what has happened with our solar system's gas giant planets. The Mamajek object is a shocker. Never before or since has a light curve been detected like Super Saturn's. Super Saturn has added a new chapter to our understanding of the formation of ring systems. So, here's to you, Super Saturn. Hope to see you again soon. TRES-2b, or not to be, is a planet where night never ends. And it's not your regular night with stars shining in the beautiful skies. Here it's pitch dark and scorching hot. TRES-2b is a gas giant, roughly 1.5 times more massive than Jupiter, and its surface absorbs light better than charcoal. It might also have a faint dark red glow because of its burning air, which is as hot as fresh lava. Lovely. In the star system of 55 Cancri, there are 5 planets, 4 of which are gas giants similar to Jupiter and Saturn. But the 5th one, or rather the first because it's closest to the star, is different in a most horrible way. 55 Cancri e is so close to its sun that half the planet's surface is a literal ocean of molten lava. The other half is in eternal darkness because it never sees the sun. The planet is always turned to its star on one side. And between the scorching and the dark, there's the twilight zone, a thin strip of gloomy nothingness. That's a getaway spot. HD 189377b, well, I'm not going to say that again, is the only exoplanet in the orbit of its star, and at first glance it looks quite pretty, blue and white swirls making up wondrous patterns on the surface. But these pleasant colors actually come from hard silicate particles in the planet's atmosphere, which means it rains glass here. But the worst is that winds reach the speed of 5,400 miles per hour, or almost Mach 7. Well, for comparison, the fastest wind speed on Earth was 254 miles per hour, over 20 times less. Thus, the glass falling from the sky travels horizontally at hypersonic speeds, shredding everything in its path. Better duck. The next system, whose name I won't even try to pronounce, this one, has 3 exoplanets, which are all being slowly destroyed by their own star. It happens because that star is not a regular. It's a pulsar, a rapidly spinning core of an exploded star. It creates powerful electromagnetic pulses in several directions while rotating at several thousand times per second. As a result, the planets orbiting this deceased star are slowly being eaten away and will eventually disappear entirely. Kepler-70, hey, I can say that one, is a hot blue dwarf star that exploded into a red giant some 18 million years ago. At the time, it was orbited by at least 2 planets, the closer of which was a Jupiter-like gas giant. Its name was Kepler-70b, and it still exists, but the overgrown star consumed it and transformed it into a blazing hot rocky world. Right now, it's one of the hottest planets ever discovered. Its temperature is higher than the surface of our Sun. It was lucky to survive spending time inside the star, but it's evaporating now and will probably be no more in the near future. WASP-12b is one of the weirdest and saddest planets out there. The enormous gravity of its star, combined with the planets consisting mostly of gas, result in the star slowly devouring its protege. So pal, what's eating you? My mother. WASP-12b has already taken the form of an egg, stretched toward its merciless sun, and it's unable to do anything with its condition. In another 10 million years, the planet will inevitably succumb to the voracious star's appetite. Hey, you asked. If you ever wondered what it's like to walk on ice and hot coals at the same time, Gliese 436b is a planet that would give you a vivid example. Being extremely close to its sun, the Neptune-sized exoplanet boasts temperatures hotter than a blazing oven, and yet it's covered in ice, which burns incessantly. This ice is much denser due to the enormous gravity of the planet, staying solid even under extreme conditions and not melting away. No list of frightening worlds could do without mentioning Venus, the Earth's evil twin. The second planet from the Sun has an atmosphere so thick and full of clouds that its surface is much hotter than that of Mercury. Volcanic eruptions constantly thrash Venus. Its gravity is almost 100 times stronger than ours, and those clouds I mentioned are not made of water but of sulfuric acid, which condenses and rains down on the ground, adding to the inferno. But even if you were brave, or crazy, enough to try to pass through these clouds, you probably couldn't. The winds up there are as strong as some of the most powerful hurricanes back on Earth. Here we have a very long name for a very, very cold planet. Although the host star is not too far away, it's a small and rather cool red dwarf, whose light and heat barely even reach the planet. The temperatures out there fall as low as minus 370 degrees, which is only marginally warmer than absolute zero. The exoplanet is thus dark, gloomy, and covered in eternal ice that never thaws. I thought I thaw that somewhere. Still, if it has a rocky core, it might generate some heat, so there's a chance that deep below the frozen surface, some unknown alien things might lurk. Dimidium, located roughly 50 light-years away from our solar system, is a planet hostile to any living thing on many accounts. It's tidally locked to its sun, which means one of its sides is always facing the star, while the other is always turned away. The hot side is heated to over 1,800 degrees, perpetually blown over with winds reaching 600 miles per hour. And that's winter. Well, actually, I don't know that. Despite Dimidium being a gas giant, it has a large amount of iron in it, which melts and evaporates in the atmosphere, creating clouds. And when those cool down, they fall on the surface in the infernal rain of molten iron. That'll test your mettle. Oxygen is usually viewed as an element that might bring life to a planet, but this is definitely not the case for Osiris. Scientists were shocked to find oxygen on this planet, or rather around it, because it's 8 times closer to its star than Mercury is to the Sun. This extreme distance makes Osiris a living melting pot, where anything that could burn will. It's also responsible for a very short orbit of the planet around the star. A year on Osiris is just 3.5 days on Earth. To boot, the atmosphere of the planet is constantly blown and melted away by the heat from its sun. Vacation? Nah, let's keep looking. Karat XO 3b is neither as hot nor as cold as some of the others on this list, but it's terrifying in its own more insidious way. It's a gas giant similar in size to Jupiter, yet 20 times denser. This makes this exoplanet's gravity weigh down on everything on its surface 50 times more than it would on Earth. Stepping on it would be your ultimate doom, because you'd be immediately crushed by the density of its atmosphere. Karat 7b is another oven-like world. Its day-to-day temperature is over 4,000 degrees. Combined with the rocky surface, it presents an infernal landscape. The rocks on the ground bubble and boil, evaporating in the atmosphere, where they cool down and eventually fall back on the surface in a brimstone rain. The saddest thing about Karat 7b is that it might have once been a gas giant whose atmosphere melted away from the heat, leaving only the scorched core. Now, Mercury is the planet that's usually closest to Earth. Does that surprise you? Did me. Venus certainly gets closer to us than Mercury. It can be as close as 25 million miles. After all, Venus is the second planet from the Sun, and Earth is the third. Even Mars gets closer to Earth than Mercury. The red planet can come as close to our home as 35 million miles, as it will in the year 2287. I won't be around for that. The average distance from Earth to Mercury is 48 million miles, but Mercury is still usually the closest planet to Earth. That's because Venus is usually somewhere on the other side of the Sun for 112 days, and Mars is usually far away in its highly elliptical, almost 2-year-long orbit. That leaves Mercury zipping between the Earth and the Sun every 44 days, and thus usually closer to Earth than either Venus or Mars. Hey, good trivia question to pull on your friends, isn't it? 22 spacecraft have successfully flown to Venus, and over 30 spacecraft have flown to Mars, but only 2 have ever gone to Mercury. So, what's so hard about going there? Well, it has to do with the Sun. Mercury is not only the planet that is usually closest to Earth, it is also the planet that is always closest to the Sun. 28.6 million miles close, to be precise. Being that close to the Sun creates navigational challenges, to put it mildly. Any spacecraft going to Mercury gets accelerated by the tremendous gravitational pull of the Sun. The spacecraft will be moving too fast to go into orbit around Mercury. That's why the first spacecraft that went to Mercury, the USA's Mariner 10, merely flew by Mercury 3 times, but made no attempt to achieve orbit around Mercury. The only other ship to go to Mercury, the USA's Messenger spacecraft, took 6.5 years to get there. Now that's a trip. Messenger did achieve orbit for a period of 4 years before finally running out of fuel and crashing onto the surface of Mercury on April 20, 2015. Many other spacecraft have flown to Jupiter in about the same time or less than it took Messenger to go to Mercury. The hang-up is the deceleration of the spacecraft. Quite simply, it takes too much onboard fuel supply to fire the engines in the reverse direction and brake the speed of the ship against the Sun's great gravity. Slowing down sufficiently to get into orbit around Mercury is a no-go using rocket power. Some other way had to be found to slow Messenger down, a way that didn't use much or any fuel. Messenger was a hefty 2,400 pounds or so, loaded with 9 pieces of state-of-the-art scientific equipment. Now, 55% of the total weight, or about 1,300 pounds, was fuel. But this fuel would not be used to slow the spacecraft down. The fuel would be used for 5 engine burns associated with gravity assists and also for orbital adjustments once Messenger got to Mercury. Now, gravity assists uses the gravity of a planet and the planet's orbital velocity to either speed up or slow down a spacecraft. If the ship approaches a planet at a forward-moving angle, that is, an angle in the direction the planet is revolving around the Sun, then both the planet's gravity and the orbital velocity of the planet give the spacecraft a slingshot boost, greatly increasing the speed of the craft and sending it off in a different direction. This boost in speed can be added to by the spacecraft firing its rocket engines at just the right time. Both of America's Voyager probes use Jupiter's massive gravity to slingshot them to the outer gas giant planets and eventually out of the solar system. Gravity assist can also be used to slow down a spacecraft, as in the case of Messenger. By entering a planet's orbital path ahead of the planet's gravity pulls back on the spacecraft and slows it down. An engine burn is necessary at this time to escape the orbital path of the planet. Messenger performed 1 gravity assist flyby of Earth, 2 gravity assist flybys of Venus, and 3 gravity flybys of Mercury. Only then had Messenger been slowed enough to enter into orbit around Mercury. The probe traveled an astounding 5 billion miles to get to Mercury from Earth. That's farther than Pluto is away from Earth at its most distant. The name Messenger is an acronym, almost as clever as its intricate flight path to Mercury. Because Mercury is the fastest-moving planet, the ancient Greeks appointed Mercury as the messenger of Olympus. News traveled fast even back then. Messenger really stands for Mercury Surface, Space Environment, Geochemistry, and Ranging. What do you think? Did they have a contest to come up with that? Now, the good news is, there's another mission to Mercury underway right now. It is a combined ESA-JAXA space mission that is bringing 2 orbiting satellites to Mercury. The mission doesn't use an acronym for its spacecraft, it has a real name, Bepi Colombo. No, it's not a cartoon character. Dr. Giuseppe Colombo, after whom the spacecraft is named, was an Italian mathematician and professor of applied mechanics. He worked with NASA on the Mariner 10 mission to Mercury. Bepi is Giuseppe's childhood nickname, which everyone knew and loved him by. NASA had been content with 1 flyby of Mercury, the first ever, but Professor Bepi calculated that with a slight adjustment of the flight path to enable a gravity assist at Venus, Mariner 10 could fly by Mercury again and again on different orbits around the Sun. Thanks to Bepi, NASA got 3 flybys of Mercury for the price of 1. Bepi Colombo, the spacecraft, is scheduled to perform 9 gravity assist flybys, 1 at Earth, 2 at Venus, and 6 at Mercury itself. Each planetary deceleration slows Bepi Colombo relative to the speed Mercury is moving around the Sun. This will allow for orbital insertion. Otherwise, Bepi Colombo would head off into the Sun. Now, once in orbit around Mercury, Bepi Colombo's Mercury Transfer Module, or MTM for short, will release 2 satellites, 1 European, the MPO, Mercury Planetary Orbiter, and 1 Japanese, the MEO, Mercury Magnetospheric Orbiter. Both are expected to orbit Mercury for 1 year. Altogether, the MCS, Mercury Composite Spacecraft, consists of the MPO, the MEO, the MTM, and MOSIF, which protects the spacecraft from the Sun and houses the electronics for MEO. This alphabet soup of mission components highlights the other reason it is difficult to get to Mercury. After 6 gravity assist slowdowns, 6 engine burns, 18 orbits around the Sun, 6.5 years of travel time, and 9 billion miles of distance, you have to bring a tailored complex of equipment. It's like that mountain picnic you'd like to go on. You can't just drive there. You have to hike a long way up a tricky mountain trail and bring along insect repellent, sunscreen, and your hat. Oh, and lunch and beverages. It's not easy. Bepi Colombo has packed it all, including lunch. Nah, not really. The design is incredibly complex. Nothing can face the sun, not even the solar panels. The solar panels must be kept turned almost to a right angle to the sun, or the heat and particle flux will corrode the solar cells, and without electricity, you have nothing. Therefore, at right angles to the sun, the solar panels must be extra long, as if there were only a little bit of sunshine. Bepi's solar panels are 50 feet long. The sun shield must remain gyroscopically aligned towards the sun so that all instruments are always in the shade but still have a line of sight to what each is meant to monitor. And there are a lot of instruments, 5 in the JAXA orbiter and 11 in the ESA orbiter. It's one amazing picnic. Anyway, the science objectives are meant to add to what we have learned from the previous 2 missions to Mercury. The data collected by Bepi Colombo will enable scientists to study the planet's interior and composition, along with Mercury's geology and surface morphology, Mercury's magnetic fields formation and evolutionary history, the planet's solar wind interactions, and overall environment. As a metal-rich planet, Mercury may hold a vast wealth of minerals that MESSENGER failed to detect. Bepi Colombo launched in October 2018 and still has a long way to go before it goes into orbit around Mercury. However, Bepi has already flown past Mercury and returned new photographs. The European Space Agency is excited about its first hot mission. All of the ESA's previous missions have been cold missions to objects further out into space, such as Mars, the asteroid belt, Comet Rendezvous, and elsewhere far out in the solar system. Well, all I can say is, best wishes to Bepi Colombo. Let's hope all goes well on its 800 degrees Fahrenheit mission to Mercury. Let's hope that Mercury's long tail of exosphere gases, sodium, magnesium, and potassium, blown off the planet's surface by the solar wind, don't fog up the lenses or coat the solar panels. Have a nice time. Ciao, baby.